Hi, I'm Chris Brenton. I'm your instructor for the day. Sorry for that. But we're going to be talking about threat hunting, specifically intro to threat hunting. We have a couple of different level classes we teach. This is kind of the intro to kind of get everybody in and up to speed. Thank you to our sponsors. We've got a couple of sister companies we're associated with. Black Hills, most people have heard of that. Antisyphon, they do a lot of training. Wild West Hack and Fest, which has an event coming up, which I put a slide in for and then decided to pull it back out because Wild West Hack and Fest is booked. It is booked solid, no getting a ticket. For a while there, you could get a ticket if you attended training, but then all of that filled up too. So I've mentioned this a couple times. You got a couple of options for doing the lab. One is you can download one of the two virtual machines, get that up and running, and you'll have the VM and all the software you need to be able to go through and do the labs. The other possibility is to build it yourself. So you could go to, Amazon, Azure, DigitalOcean, pick the, Linode, pick the public cloud infrastructure of your choice and spin up one of these three operating systems. And then you can go through and run the commands I'm about to show you. There's like 5 of them to go through and get everything set up for the lab that you need. Will today's training be recorded? Yes, it will. It always will. And if you go to our website, acm.re, go to education, go to threat hunter training. There's a page there that has everything about this class, including the last recording that was made and the last copy of the slides. The recording that's there is obviously for the last class because we haven't recorded this one yet. And it would be just really weird if we could post the video before the video was recorded. So yeah, it's still the old one, but that'll get changed. Here's the links to the VMs. So if you go to the ACM webcast content channel, you can download a copy of these slides. You can click on these links. You can pull these down. They're zipped up, unzip them. They're going to create a directory, throw all the files it needs for the VM in there, and you're off to the races from that point there. I used to provide a VirtualBox image as well. I decided not to bother because if you just take the OVF file and import it as an appliance, that works perfectly fine. Doesn't make a whole lot of sense to have an extra VM out there that people have to worry about. But like I said, if you want to build it yourself, it's pretty straightforward. So go through, build up an Ubuntu, CentOS, or Rocky. You want to have an account that has sudo access to that machine. This first command pulls down all of the lab files that we're going to be working with. And this tar command just brings it up. This command goes out and downloads an install script. This command makes that script executable, and then this command runs that script. So what that script will do is it will go through and find all the pieces it needs for Rita, install it on your system. And if it doesn't find Zeek, it'll go through and install all the pieces it needs for Zeek. The Zeek we're running in this class is different than the Zeek you've used before because this is Zeek running inside of Docker. So the Zeek command that you're working with is not the normal Zeek binary. It's actually a script that interacts with the Docker instance. And I'll talk more about that when we get more into the lab stuff. When you go through and run it, it'll prompt you for your become password. That's actually asking for your sudo password. So go ahead and enter that through. It'll ask you to select the interface that Zeek should listen on. Just pick your network interface, although we're not going to be doing that as part of these labs. When the install script finishes, it'll pop up a little info banner that says, hey, you're all set. Type in Zeek start to run Zeek. You don't actually need to do that. You don't need to have Zeek running in the background in order to be able to do the labs. I'm having issues uploading the ISO for the VMware thoughts. I'm not sure where you're trying to upload it to. You shouldn't have to upload it. You should be able to just download it to your local system, launch your virtual machine software, and then just go open up those files in the location that you opened it up to. Some shameless plugs. I'm teaching advanced threat hunting in a couple of weeks, although, hey, that's full. But I've also got some on-demand stuff that you can go through and grab, link to that. So we're going to be using Rita in the labs today. Rita is our open source threat hunting tool, and it's freaking awesome. The engineering team did a great job well, with its latest version. And we'll go through and we'll work with that. But we do have a commercial product. If you're interested in that commercial product, which is also in the process of getting completely revamped, just type demo into chat and someone will tag that and reach out to you, and we'll see about getting you set up to do a live demo. And that's it for the advertising. So logistics for the class. This is a 6-hour class. So it's going to be running for a while. You don't want me talking nonstop. You want to be able to take some breaks from my voice. So what we're going to do is at the top of each hour, we're going to go through and take a 10-minute break. In the middle of the class, at the 3-hour point, we'll take a 20-minute break instead. That gives you a little extra time to, water the kids, feed the dog, whatever it is you need to do. And Discord's being monitored if you happen to have any questions. We're going to be working at the command line, specifically the Linux command line. And this is a new experience for some folks. And hey, that's fine. We all start somewhere. This was new to all of us at one point or another. I'm going to go through and explain the commands the best I can and what they're doing and how they're working. But one of the things that I notice tends to kind of confuse folks sometimes is I like to use nested commands. What's a nested command? A nested command is just simply, I'm going to run a command, and rather than print the output of that command to the screen, I'm going to take that output and redirect it through another command. And then I'll redirect that through another command. And I'll explain what's going on. If you're having trouble following it, try typing out the full command and then removing one set of commands at a time, just to see how that output changed. And that kind of helps you wrap your brain around what each command is doing. It's like, oh, hey, when I removed this, all of a sudden the data is not sorted and it's all out of order. Oh, okay, so that's what that command was doing to help me out. Okay, that's cool. And you can kind of work through it that way. The other thing you can do is you can go up to explain shell and just take the command, copy, paste it in, and they have some really good descriptions about what's going on with all of the Linux tools. So a couple goals for this class. We want to go through and define cyber threat hunting. What is it? Because, oh my God, some people get that so wrong. I also want to kind of talk about, so what is threat hunting and how do you go about doing it? We'll talk about some common terms for command and control and how that works. We'll talk about how to go through and do a little bit of an endpoint investigation, specifically how to do endpoint investigations without actually touching the endpoints. And then we have a bunch of hands-on labs to go through and kind of cover all the stuff that we talk about. So what is threat hunting? The biggest mistake I see people make is they think this is pretty much the same thing as logging and alerting. In other words, I see a lot of people who say, well, you write signatures for your SIM, and when those signatures trigger, you investigate them. No, that's log review. That's different. We've been doing that forever, and it turns out it doesn't really work. It's just too much data to go through. Threat hunting is a totally different beast. Threat hunting is something that I say, it is Tuesday. It is the first quarter. It is, some interval that it now becomes time to go in and do threat hunting. I may decide to trigger it early because I see something suspicious on my network, and that's fine. But I'm not going to end up in a situation that I never do threat hunting because some specific alert did not trigger. I'm always going to be doing it on, I recommend quarterly to folks as a minimum. At least go through on a quarterly basis and do it. Ideally, we're doing it daily, but unless you get the right tools, doing it on a daily basis is really hard. The purpose of a threat hunt is to validate the integrity. And again, this is where log review tends to fall down, because we say, oh, well, it's our centralized logs. It has everything in it, and it never, ever, ever does. There's always hardware missing. There's always a couple systems people brought up that they didn't point at the logging server. There's, IoT and IoT devices that may not be logging anything. So the purpose of a threat hunt is to validate everything, not just the stuff that submit logs. You're going to be able to hit everything connected to your network. The output of this is a compromise assessment. So the goal of a threat hunt is, once you're done, you're able to say, I'm pretty certain our integrity is still high. None of our systems that are connected to the network are compromised. Or you may say, I'm pretty certain these 1 or 2 or 5 or whatever systems may be in a compromised state. We need to go into incident response mode, and we need to go in and deal with that. So at the end of the threat hunt, one or two things are going to happen. We're going to say, yay, high five each other because we think everything's awesome, or we're going to be in incident response mode. Those are our only two possibilities, really. There's a third kind of side one to it, which is sometimes you go through and you do a threat hunt. I don't know what's falling down in my office. You go through and you do a threat hunt, and you end up with an undetermined. In other words, you're looking at something and you're saying it might be good, it might be evil. I can't tell the difference. You need to come up with additional tests to be able to validate that. And I'll talk about what some of those additional tests might possibly be. But if that happens, your threat hunt's not done. You're just going in and making sure you're collecting additional data. At the end of a hunt, one of two possibilities. Yay, we win, everything's safe, or boo, we lose, we need to go incident response mode. Yay or boo. Those are your only two options out of a threat hunt. Awesome. Let's see, it's no sound for me. Okay, and folks are helping out with that. Awesome. But I have my SIM. So yeah, like I said, there's a lot of problems with doing centralized logging. So where I'm coming from with this is I've done centralized logging almost forever, or at least it feels like forever. I've done it since the 80s. Syslog, I think, was created in like 87, 88. And it was probably within a year or two after that I started doing centralized logging. So I have a lot of experience with it. The first SANS class on doing centralized logging and alerting, I was the author. So I've been at this for a while. And one of the things that have always kind of drove me nuts is all of the weaknesses with trying to do centralized logging. And I've got them outlined in the different bullet items that are here. You don't need me to go through and do a lot of detail. But the biggest one for me is that we've been doing it forever and things are getting worse, not better. And it's part of all these different security attestations, right? So here's a test. Name me a security attestation that doesn't include the requirement for centralized logging and reviewing those logs. I'm not aware of one. So everybody's doing this and it's getting worse. Logic dictates maybe it's not helping as much as we hoped it would. Well, luckily we got AI now, right? And AI is going to go through and fix everything. Well, no. So first off, there is no artificial intelligence. This is a marketing term. It's like deep packet inspection. Deep packet inspection is not a technology. Deep packet inspection is a marketing term. Deep packet inspection was created by a firewall vendor that did stateful inspection, that the marketing people decided, well, stateful inspection isn't getting people's attention anymore. So let's rebrand it deep packet inspection. And now it sounds like we have something new that nobody else has. And all these other firewall vendors and IDS vendors needed to say, well, we do deep packet inspection too. And now it's like thought of as a real term, even though it's just a marketing spin. AI is the same type of thing. It's all just machine learning. And, I've got a lot of different instances here. I'll leave it to you to click through and read them if you want to, where AI has gone sideways. Here's your problem. Your problem is if AI isn't working from a security perspective in your environment, how are you going to know? Right? Like if the AI turns racist, you figure it out pretty quickly, right? You see the statement it makes and you say, wow, I would never say that. That's a racist term. And the AI has gone off the rails and things are going bad. But with security, when things go bad, if it doesn't find it and doesn't tell you about it, there's no real litmus test for that, right? If it's not going off, you're assuming everything's okay, but maybe it's not. I think AI has possibilities. I think it is going to be incredibly helpful in our field. I think today we're trying to apply it wrong because we're trying to make as big a splash as possible. And I also think it needs a lot more vetting. One of the challenges we run into today is that AI is kind of a self-learning black box. Right? We put data in and something comes out the other side. And if it's the results we wanted, we say it's working well without actually taking the time to kind of verify things. I'll give you a great example. So this last bullet item, right? diagnosed tuberculosis based on age or MRI. You probably saw news reports on that, right? There was a ton of news stories that came out that said, wow, AI is awesome. It's using MRI scanned images to help doctors identify when people have tuberculosis, and the accuracy rating on it is incredibly high. It was like 80, 85%. And that was a correct statement when they went through and they did testing and they fed in some number of images that was from a person who had tuberculosis and some number of images from people who didn't have tuberculosis. About 80, 85% of the time, it was getting it right when it said, yes, this one does, no, that one does not. So we said, yay, AI is working. Well, no, what's different about AI versus the way we did things in the past is you need to figure out what's it actually doing, right? It's not like code you wrote and you understand what that code does. It's kind of writing its own code. So you need to stop and go back to see, well, what code did it write? And after all those news stories came out, some folks actually went in and started doing some A/B testing on this algorithm. And what they found was that the litmus test it was using to decide if someone has tuberculosis was the age of the MRI machine that generated the image. In other words, if it was an MRI machine that had been manufactured within the last 2 years, it gave a very low score to the probability of the person having tuberculosis. But if it was an MRI machine that was created 20, 25 years ago, it scored a very high probability that that person had tuberculosis. Well, Chris, that has nothing to do with it. Well, it turns out it does a little, right? If you have a very wealthy nation, your hospitals have the latest and greatest equipment. You have good hygiene. The problems with tuberculosis are fewer. If you have a nation that is very poor, that doesn't have a lot of money, if you have anything in your hospital at all, it's the oldest equipment you could, because that's the only thing you could afford. And because it's a poorer environment, people are far more likely to have health issues and run into things like tuberculosis. So it's more of it. So from the test perspective, old machines versus new, it was working great. But real world, where maybe this person has tuberculosis, maybe they don't, it failed horribly. And in fact, what they found was that when they combined the MRI system with actual doctors and let the doctors make the decision, but use the MRI, use the AI system as just an additional data point for them to work with, their accuracy rating dropped by, I think it was either 5 or 8 points, somewhere in that range there. So in other words, if that doctor, 85% of the time was able to tag when somebody had tuberculosis, it dropped to 80% once they started relying on the AI system. So this isn't going to fix us anytime soon. So, what's the purpose of threat hunting? Well, the reason we need threat hunting is to fill this gap, right? When you look at the tools we have out there today, they have one or two use cases. They're either all the stuff we use to try and keep the bad people out, or all the stuff we use once we realize they're on our network. Well, the issue is that gap in the middle, right? How do we figure out when all of these things have failed and we need to start using these tools? That's the job of threat hunting. The job of threat hunting is to, as quickly as possible, detect when all these layers have failed and those tools need to get triggered. So, what we advocate is starting on the network. And a lot of the reason for that is the network is the great equalizer. One of the, yeah, I run into this with programmers. I got programmers that are really good at Linux, but they're horrible at Windows. Or they know Windows, but they don't know Mac. It's when you get into like a host level system, there are their own unique ecosystem that requires a unique set of skills. So someone who could be very skilled at threat hunting a Linux system or doing a forensic analysis on a Linux system, those skills don't directly translate 100% to trying to do the same thing on Windows. Certainly some of the skills do, but they're not going to be able to do as good of a job on a Windows system unless they've had that specific training. So when you get into endpoints, it's all over the place. And log entries mean different things, right? Like if someone's doing a buffer overflow attack against my bind server, that error message that gets thrown by bind isn't going to be the same as like Windows DNS, but it's also not going to be the same as like Unbound, which is also, can also run on the Linux platform. So When you get into the app level, everything's very specific. Then on the network, packets are packets. It can be a Mac, it can be a Windows, it could be a Linux, it can be an old Amiga system. It doesn't matter. Packets are packets. Hunt them is always the same. So when I see a stream of packets coming from a system, and I want to go through and identify, is that system potentially compromised, and has there been a command and control channel set up? I don't care if it's Windows, Linux, or whatever. I'm going to hunt it exactly the same way. So it's nice to have that common reference starting point to be able to go through and do all of this stuff. The other thing I like about it is you can't stealth packets, right? Like we've seen many times where attackers figure out how to run their process on a system in a way that doesn't exactly register properly with proc, which means all of these tools that are designed to show you what's running on those systems won't actually show you that hidden process, right? It's a hidden process. You can't hide packets. You can try and make them look normal, but you can't hide them. They're still there. So as long as you know what to look for, there's still something you can go through and do with that. So what does this threat hunting process look like? For me, it kind of looks like this. The first thing I want to go in and look for is connection persistency. What's connection persistency? Connection persistency is simply, hey, one of my internal systems is talking all the time to a host out on the internet. In other words, there's been a relationship established between those two systems. It's not ad hoc, right? It's not like a user talking to Google, right? You're like, I might do, you know, 3 Google searches one day and 20 Google searches another day. And when they happen are kind of sporadic throughout the course of the day. There's a very ad hoc telemetry if you go in and you look at the timing and the quantity. What I'm talking about is something that looks more persistent than that. Like, hey, every 15 minutes, my system is talking to that host out on the internet all day long. Or, hey, my system created a connection to that system out on the internet and it's leaving it open all the time. These two systems are in constant communication with each other 24 hours a day. That's connection persistency. When you identify connection persistency, the next thing you want to look for is, can I identify a business need associated with that? In other words, if what I'm seeing is my system checking with an NTP server to see what time it is, that's fine. There's a business need for that. Or my system checking to see, hey, are there any new patches available? That's fine. There's a business need for that. But if my system is reaching out to a system that, it's reaching out to evil.ru, and evil.ru is not a field office, a business partner or vendor or anything like that. Well, why? Why is that happening? Now we need to go in and we need to kind of dig things down. We also want to go in and look for, if we see something like that, one of the things we want to evaluate it for is abnormal protocol behavior. Are things working the way they expect? When you kind of look at communications, there is normal. This is how this conversation usually takes place. And then there's abnormal, but still in spec, meaning, well, they're not breaking any of the RFCs, but that's not normally how that stuff works. You want to be able to pick up on that stuff as well. And I'll talk about some examples of that as we go through. And again, as I said, the idea is for every single one of our endpoints on the network, one of two dispositions. We're either saying, I'm pretty certain this is in a safe condition, or it's not. For the systems that are out on the internet side, if I go through and I check out this connection persistency, right? Like it's, hey, that's just a time server. All of my Ubuntu systems go check time at that same time server. So this connection persistency, this is business need for. What I may want to do on the other end is say, I'm going to add that to a safe list. In other words, I hunted it today. I figured out it's just a time server. Well, I don't want to have that IP address pop up tomorrow and say, oh, what's that? Oh, it's just a time server. Oh, okay, let's do a hunt the next day. Oh, what's that? Oh, yeah, it's that time server again. Oh, yeah, it's that time server again. You don't want to be wasting your time. So what safe listing does is hey, I validated that there is a business need for me to be communicating with this host out on the internet. So when that happens, I don't want that data showing up in my threat hunt anymore. I may continue to collect that data just in case I want to go back through it later for some reason, but it's not going to show up as part of my threat hunt anymore. So what does starting on the network do for us? Okay. Don't worry about what tool this is. What I want you to focus on is I have an internal system. You can see I got a private address here. I've got an external system. Here's a legal address. And this internal system is creating connections to that external system. This is over about a 24-hour period of time. It created 9,000 connections. Ooh, that's a lot. Well, to me, yes, it's definitely a lot. It's definitely worth investigating. But to me, what I always look for is it bursty or is it persistent? In other words, if I see a lot of, let's say I see 100 connections take place in a 2-minute period of time, I'm not going to worry about that. Maybe that's an old HTTP, 1.0 web server or something weird like that. And that's what's causing all of those connections to get launched off that way. I don't know. But it's a burst of traffic and that's it. And I don't see anything else the rest of the day. I'm not going to worry about that. But if it's 100 connections spread out about 15 minutes all day long for the full 24 hours, that I'm going to pay attention to because that's more indicative of a potential command and control channel. And that's what this graph down here on the bottom shows us. So each of these bars represents a 1-hour period of time. My y-axis is quantity. So what I'm seeing in each of these bars is displaying is during this hour, this is how many times this internal system connected to that. And it breaks it out into 1-hour increments all the way through. Well, notice I get a little red line here. It's almost flat all the way across. That's connection persistency. That's when I want to pay attention. This graph over here, this is organizing the data slightly differently. What it's saying is, what was the delta time between connections? Right. So if I have, let's say, network time protocol, my system is going to go off at a very strict time interval. It'll be like every 15 minutes, every 20 minutes. If I'm on Windows, it's going to be every 30 minutes, but it's going to be exactly every 30 minutes. It calls out to that same system to check and see what time it is. It's very strict in its time interval. Well, what this is showing me is that out of those 9,000 connections, about 450 of them were 27 seconds. A little under 1,000 was 28 seconds. About 1,000 was 29. I've got, I don't know what I'd round that to. Let's call it 637, just so it's not a round number. 637 times it was a 30-second interval. There was a very small number of times it was a 31-second interval. Notice the timing is getting shifted around. This is also indicative of a command and control channel. It's what's referred to as jitter. And attackers do this to try and hide from tools that try and catch them. And I'll explain why that works in some cases a little bit later in the class. But seeing this tells me, yeah, this may be something I need to worry about. It's going out to DigitalOcean. Maybe I don't have any resources in DigitalOcean. There were no DNS queries performed that returned this IP address. Well, that's odd because we access most resources on the internet by a fully qualified domain name, right? So normally, anytime we hit a website, DNS had to convert that to an IP address for our system to connect to. Well, what this is telling me by there being no DNS name here is this already knew an IP address to connect to. Okay, that doesn't mean it's evil. We do direct IP address connections sometimes, but it's the exception, not the rule. And while that won't make me say it's evil, it will tilt the scale a little bit more in that direction type of thing. So, is this something I need to worry about? Well, I'm pretty certain that there's something wrong with the system, but I don't definitively know yet if this is something that is truly a compromise or not. Well, here's where a centralized logs might actually come in handy, right? Rather than trying to write alerts and signatures and all this crap that generates false positives that go off at 2 a.m. all the time, maybe what we do is we just collect up some useful telemetry, like, hey, what applications are running on each system that talks on the network? Because those are actually the important things we need to know. Because if somebody compromises that system, it's going to be over the network. If they try to move laterally, it's going to be over the network. If it's calling out to a command and control server, it again will be over the network. So knowing that app data, that could be super helpful to us. If we're logging that, well, now I can cross-reference the two. I can say, hey, when this source IP address was talking to that destination IP address over that date time frame, the same stuff we were looking at right here, right? What app was running on this system that was causing that connection to take place to that host? Well, in here I can see it's runtime broker. Well, if I do a little research, Runtime Broker is a Windows binary that helps to enforce permissions against applications you've downloaded from the App Store. So if you said, hey, that application, I want to give it access to, my file system, but not to my address book, Runtime Broker is the one to make sure that's responsible for making sure, hey, it's not actually trying to ever get to your address book. Well, but there's a problem here. Why would it be calling out to DigitalOcean? That makes no sense. Maybe it calls home to Microsoft to get some permission list or something like that. I could see that happening. But why would it be calling out to DigitalOcean? There's no logical sense for that. And also, why would it be doing it as a direct IP address connection? That just doesn't sound fault tolerant for a very large company like Microsoft, right? You'd want to send it to a fully qualified domain name. So if you need to bring servers up and bring servers down, or hey, normally, we load balance across 5 servers, but during, the start of the business day on Monday, Eastern time, the traffic doubles, so we actually need 12 servers instead. So we're going to spin up some additional cloud resources. Well, if I'm doing a direct IP connection, none of those are a possibility to me. I'd want to be using fully qualified domain name, and this doesn't. So there's a lot of stuff telling me this is probably not the runtime broker I should researched on the internet. In other words, this is not the binary responsible for enforcing permissions on apps downloaded from the App Store, the Microsoft App Store. This is something with the same name as that binary that is doing something very different. We need to go in an incident response mode. I would go in and make sure that I would now go through and do some sort of a binary analysis on that. Now, as part of threat hunting, one of the things I'm really big on is don't cross the passive active line. What do I mean by that? I mean that everything we do as threat hunters should be things that the attacker can't detect. So in other words, if I'm checking centralized logs, they don't know that. If I'm grabbing packets off the wire, they don't know that. If I'm going through Zeek logs, if I'm passive fingerprinting packets, they don't know that. They can't tell whether that's actually happening or not. But if you sit down at the console of that system, log in, open a command prompt, and start running task list, or something like that, well, if they have remote control of that system and they can see the screen, they can see that you're doing that. They can see you're trying to figure out if they're there or not. That will tip them off that you're on to them. You don't want to do that during a threat hunt. Deciding that we need to sit down and touch the keyboard needs to happen as part of incident response mode. Why? Because there's all sorts of things that can go wrong. We can impact the integrity of the forensic stream. I've seen situations where we think it's one system compromised, it's actually 12. We touch the keyboard on the first system, and the other 12 start going scorched earth on the rest of the network. Whereas if we had gone in incident response mode, someone might have said, well, gee, do we know for sure it's only this one compromised system? In which case we would have found those other 12 and made sure everything got shut off at the same time so that the attacker still have a backdoor into our environment. So you get the idea. Isolating a system. I mean, that sounds kind of basic. What could possibly go wrong there? But as soon as you isolate that system, the attacker knows you're doing something different with it. And you might be doing something different because you might be catching on to the fact that I've compromised it. And again, if I have other paths into the network, I'm going to start going scorched earth from those. So threat hunting, passive activity only. We should only be doing things an attacker can't pick up on. So let's talk about some techniques. So we talked about we want to use network data. What do we mean by that? Well, this could be PCAPs. This could be something like Zeek. Zeek is a network recorder. It's not an intrusion detection system. So what Zeek does is Zeek goes through and makes a summary of every single connection that takes place. So with a PCAP, I'm going to get data packet, which is why PCAPs take up so much space. Zeek will go through and say, well, rather than recording each individual packet, I'm going to store a summary of that session between those two systems. So there'll be maybe 100 or 200 bytes of text associated with each connection instead of a binary that's the full size of every packet that actually went by. So one of the things you find is that Zeek is about 20 times more efficient in disk storage than PCAPs could be. And that's huge, right? Like if I have enough disk space to save 5 days worth of PCAPs, that's not a lot to work with. But if I'm using Zeek instead, I could save 100 days worth of Zeek logs. Yeah, that's a good history to be able to go back through if I need to. How much data should I be working with? In other words, when we were looking at, don't flip, I'll come back to where I was. But when we were looking at this, we had 23 or so worth of hours worth of data we were working with in one big chunk to be able to process this and say, look, there's some persistency here. So that's huge, right? We're not trying to do like an instantaneous signature match and then forgetting about what's going on. We're taking big chunks of data and working with it. Well, how big do those chunks of data actually need to be? Well, 12 hours is the minimum I recommend to folks. 24 hours is better. If you're a 3-letter government agency or your domain ends in .mil, yeah, you might want to go more than 24 hours in the chunks that you're analyzing. But for most of us, the average organization with the average threats to worry about, 24 hours seems to work out pretty well. Because one of the things you want to make sure you don't get into is the bigger the chunks of data you're working with, the longer it takes you to process them. And you don't want to end up in a situation where it's taking you longer to process the data than the collection time. In other words, if it takes us 25 hours to process 24 hours worth of data, guess what's going to happen really quickly? We're going to end up behind the 8 ball, right? It's going to take less than a month and we're going to be behind the 8 ball. We're going to start missing stuff. And analyze communications in pairs. And pairs can be source and destination IP address, but it could also be source IP, destination, fully qualified domain name. That way, if the connection is going to multiple IP addresses, all associated with that name, we're pulling those together as a collective as part of our analysis. Typical deployment for something like this. So I've got here's my firewall, here's the wild woolly internet. I've got systems connecting out through the firewall. So what I do is I take a capture system and I put 2 network interfaces on. One network interface just plugs into a regular switch port. It gets an IP address assigned to it. This is my management interface. So if I need to SSH into this box or do an X session or whatever, this is how I'm going to connect up into it. That second interface may not even bother getting an IP address assigned to it. It's going to get plugged into a port, and then we're going to go to the switch and say, hey, all data going in and out of this port, send a copy of that over here to this port as well. And now this system's going to be able to sniff this traffic. That's referred to as a span port, a copy port, a mirror port. Different vendors use different lingo. So use whatever lingo you're used to from your switch vendor. Doesn't matter. The idea is you're going to tie those ports together so you can get a copy of the packets. That way, we have now full visibility of everything going in and out of the internet. And we're seeing it from the perspective of the private addresses of our internal network. If we said sniff here instead, well, now everything's already gone through NAT. Everything's going to look like it's coming from the same IP address. So if I see something that looks like a command and control channel, surmise one of my systems are compromised, but I don't know which one because everybody's getting added to the same IP address. Now I get to go to the firewall and say, hey, when you connected to this IP address from this port to that port, which internal system were you natting at the time? And that just makes this whole process a lot more difficult. Sniff on the inside, you'll be in much better shape. Does targeting C2 have blind spots? Yeah, there's actually some malware out there that doesn't use command and control channels. It is incredibly rare, right? Like the Morris worm was one of them, right? And what the Morris worm do? The Morris worm went scorched earth on the internet. They talk about the whole CrowdStrike thing being the first time the internet was brought down. No, you're just too young to remember. Oh, isn't that cute? You think this is the first time the internet's brought down? No. The Morris worm has that. People were disconnecting themselves from the internet. They were so afraid of that thing. But that had no command and control channel. And that's one of the reasons why it went squirrely and got away from the programmers. I think really what it comes down to is we do that. We realize it's a bad idea because we end up hurting ourselves as well. And then we don't do it for a long period of time. And then somebody young says, hey, why don't we try this? what could possibly go wrong? And then they try it and they figure out that, oh, yeah, it can go horribly wrong. NotPetya is a great example, right? So NotPetya was the Russians targeting Ukraine again. And what they did is they got into a server that had like tax information that anybody doing business in Ukraine needed, in order to be able to pay government taxes. And I'm sure the Russian programmers said, well, if we infect that system, we're only attacking people who do business in Ukraine. So, this will work out just fine. Well, no, because you have things like global shipping companies that are not only doing business in Ukraine, they're doing business in, 170 other countries in the world. And when you take them offline, guess who's one of the people hurt by that? Russia. You can't get your oil out anymore. You can't make sales. So, oops, we shot ourselves in the foot. I hate it when that happens, and that's why we haven't seen anything like NotPetya for a while. So I give it another 10 years, and then someone young again will come up and say, "Oh, hey, why don't we do this? Let's make a headless worm. What could possibly go wrong?" And yeah, we'll have to kind of deal with it again. So it is a possibility, but these things are rare. So start by checking for that connection persistency. And I break out connection persistency into two different categories: long connections and beacons. What's the difference between the two? We'll kind of talk about the two of them as we go through. So a long connection is just simply creating a connection to the host and leaving it open all the time. That's the simplest form of a long connection. Now, there are slight variations off of that. Probably a great example. So what Metasploit does is Metasploit will connect up to the C2 server, hold the connection open for 30 minutes, close it, then immediately reestablish it again. And it does that all day. Why? Well, because we saw that situation where that internal system had connected to the host out on the internet 9,000 times, and we said, "Gee, 9,000 times, that's a lot." Well, what's a lot? If we're collecting like general metrics on how many times people are connecting to each other, what's the magic number that we decide is too much and requires investigation? Is it 9,000? Is it 5? Is it 1,000? Is it 500? Is it 100? The lower the number goes, the more and more situations are going to fit into that bubble, and you're going to need to investigate and run down. So most folks tend to say, 1,000 or more, and it's worth my time to go and investigate, because that's really odd for that to happen. Well, Metasploit is connecting once every 30 minutes all day long, which means it's connecting less than 50 times a day. So if you're checking 1,000 times, 1,000 connections or more, even if you're doing like 500 connections or 100, and you're spending it all day long doing nothing else but running these things down, it's still half of the threshold that you've set up. So it's going to fly underneath your radar. They're connecting for 30 minutes because, if it's probably pretty straightforward for me to say, hey, if you look at a 24-hour period of time, and in that 24 hours, one system is connected to another and they're communicating with each other that entire time, there's one long connection that's been running for that full 24 hours. That's interesting and worth paying attention to. That's kind of well, duh. Yeah, that's definitely persistency, right? Well, so some sites might be looking at how long do the connections run for? And I'm going to investigate anything that's more than 20 hours, 12 hours, 10 hours, whatever the magic number is for them. Well, again, Metasploit is only holding the connection open for 30 minutes. So if I'm checking 8 hours or longer, that's way down in the ground noise. So when we investigate long connections, we want to look at it cumulatively. We want to look at all of the times in the course of that 24 hours that the source and the destination were in communication with each other, and add them all up together. It is possible to end up with connections that are talking for more than 24 hours in a 24-hour period of time. It can happen. I've seen it. Sometimes you get these weird malware things that have a command and control session going, but then they launch a secondary channel as part of that. So you have two persistent connections that are running 24 hours a day. So now in a 24-hour period of time, you see this one system was talking to another for 48 hours. That is definitely worth going in and paying attention to. Now, little issue with Zeek. By default, Zeek does not log a connection until it closes. And a majority of the time, that's not a problem. So when you go and you look at a Zeek log and you look at when did this connection start, you might expect all those timestamps to be in order, right? Like the first one will have happened before the second one, which will happen before the third one, and so on down. That's not the case, though, because there may be different durations associated with these, and Zeek doesn't write the log file until the connection actually closes up. So I may launch a connection and leave it open for an hour, and 10 minutes into that, launch another connection that's only open for 10 milliseconds. Well, after 10 milliseconds, Zeek will write out that log. And it won't be until the end of the hour that it writes out the first one. So when you look at the logs, the first one will actually be after the second one. So you'll see the timestamps out of order, and that can look weird. It's not. It's from a Zeek perspective, it's a feature. Now here's the problem. What if that connection's being held open all the time? I've seen situations where folks are using Zeek, and all of a sudden Zeek generates a log entry and says, hey, this system has been talking to that host for the last 90 days. Well, what? Wait a minute. What happened at day 89, 88, 87, 86? Why haven't you been telling me this? Why did you wait until 90 days to finally get around to telling me that connection was there? And the reason is it's because it just closed. And Zeek's only logging what closed. Now, there's a workaround for that. And the workaround for that is let Rita install Zeek for you, the tool we're going to be working with today. Because what we do is we install a plugin that each hour goes and looks at the state table Zeek is using and says, hey, is there anything in the state table that's not getting written out to the log? Because if there is, I want to record that to a separate file so that open connections are now getting logged. So what's nice about that is if you're using, Reader and AC Hunter, which are using that module, or if you just let us install Zeek for you and you go through the raw Zeek data yourself, you're going to have like a con-open log entries that get generated now. And now okay, these are connections that are currently active. They haven't been closed yet, but they are actually running on my network. And that way you can respond to them before they actually close. Yikes, 90 days. Yeah, I agree, Smokey. Don't want to wait 90 days to find out. I would rather see, hey, this connection has been open for 8 hours. Now it's been open for 9, 10, 11, 12, 13, and let it add up. And, that'll get my attention to let me know I need to respond to this pretty quickly. So that's long connections. The other possibility is a beacon. Think of beacon like a drum beat, right? With a drum beat, stick hits the top of the drum, you get a sound goes away until the next time the stick hits the drum. That's a beacon. So the source system will connect up, it'll send some data, and then it'll disconnect. And then it'll wait a period of time, connect up, send some data, and then connect, and then disconnect back down again. Here's what's going on with a beacon. So imagine I'm this bad guy out here, right? I've sent some malware to the user on the system. I got them to click something that they shouldn't have. They've executed my malware. I can now take control of the system. The problem is there's a firewall in my way, right? And this is on a private address. So that's going to make it really challenging for me to try to do a direct connection to that system. So I need another way to work around that. And the way to work around that is to just simply use a proxy, what's referred to in this context as a command and control server or a C2 server. So here's how that works. So when the malware gets dropped, it's told, hey, connect to this system and do it, create a connection up to that system and say, hi, I'm here, I'm compromised. Do you have anything for me to do? And now the command and control server knows to go check the work queue for that system to see, are there any commands in the queue while that system to execute? And if there isn't, it just tells it, nope, go back to sleep. And now the system will wait some specified period of time and it'll connect up again and say, hi, I'm here. Do you have anything for me to do? No, go back to sleep. Hi, I'm here. Do you have anything for me to do? No, go back to sleep. And it does that over and over again all day long. So now when the attacker wants to do something like, hey, I want to see if there's any databases on that system. Here's the command line switches I want to use to search the entire disk to be able to go looking for that. It simply connects to the C2 server and drops that into the system's work queue. Now, that's what's happening from the attacker's perspective. It usually looks like they're just looking at the command prompt for that remote system. But if you look at technically what's going on in the background, it's getting submitted to a work queue. And now the next time the system checks in and says, hi, I'm here. Do you have anything for me to do? Yeah, run this command that'll show any databases that are on that box. And now the malware will execute that command with whatever level of permissions it's running at on that system. And now it'll take the output of that command, exfiltrate that out as part of the same beacon session. And then the command and control server simply relays that off to the attacker. So I'm using a proxy, a system in the middle. We're both talking to that proxy, and it's just negotiating the connection between the two systems. That's effectively what a command and control server is doing. Now, one of the nice things about this is that there's a new connection getting generated out to a system that may not have any business need associated with it, right? So if I see that, hey, the CFO system is now connecting out to Quanzhou, China once per minute, and gee, we don't have a field office there, a business partner or anything like that. That's odd. Let me run that down. That there's some indicator you might get to tell you I need to investigate that. I can also tunnel it over DNS, which is even stealthier. And I'll get into that one later, right? When we get into like weird application stuff, I'll cover that one. But to me, that one is the most stealthiest one that's out there today. But when you look at what are attackers doing today, there's two. There's the DNS one that we'll talk about later, but there's also this one. And this one, what they're doing is they're taking their C2 server and they're putting it behind a commercial content delivery network. We've seen this with Amazon. We've seen this with Akamai. Now what happens is you see this system is talking to Akamai servers. Well, it does that all day long when it's talking to Microsoft and Apple and a bunch of other big companies because, hey, Akamai, biggest CDN network in the world, everybody uses them. So that's not that big of a surprise. This becomes really hard to run down because now if I look at the IP packets going to the system, it may only be 1/3 of the beacons that are taking place. So I'm not seeing the full picture. That's problem number one. Problem number two is there's legitimate traffic going to that IP address as well. So how do I combine those together and only look at the evil stuff? Well, the way to do that is to go in and look at the fully qualified domain name that they're trying to connect to. And if you can tap in on that and use that as the target, you're going to be able to actually track these beacons when they're trying to hide themselves by going through content delivery servers. We'll talk about techniques on that a little bit later. Now, most beacon detection is done based on timing. And I mentioned that attackers change their connection timing up. Why do they do that? They do that because most network beacon detection tools use this algorithm right here, k-means clustering, to try and detect beacons. All k-means is math that can analyze big data sets and look for repetitive patterns. So you had 1 million connections go out to the internet yesterday, but in that was an internal system talking to an IP address out on the internet once per minute all day long. That's a repetitive pattern. K-means will look at that and say, hey, you may want to go pay attention to that. Well, if the attackers jitter the connection, the timing isn't consistent. Since it's no longer a repetitive pattern, k-means misses it, which means the dirty little secret behind these network tools is that when they can't detect the beacon using k-means, they got to write a signature for it. Well, what's the problem with signatures? The problem with signatures is I can only detect the stuff I already know about, right? I'm not going to catch anything new. That's why Sunburst went undetected by so many environments, because they were running tools that were looking for beacons, but it was jittering the connection. So there was no signature for it yet. So all these tools went through and missed it. Rita, the tool that we're going to be working with today, was one of the very, very, very few tools that actually detected Sunburst before FireEye made their announcement, hey, there's the Sunburst thing out there we need to worry about. So we want to make sure we take jitter into account when we're going in and doing our detection. And one of the ways you can do that is to just simply throw it into buckets, like 1 hour buckets, right? Because let's say I'm beaconing once per minute, plus or minus 50%. Well, that means my connection time can be as short as 30 seconds, as long as 90 seconds. Well, I'm probably going to get about as many 30-second ones as I do 90-second. So if I just lump them all into a 1 hour bucket, some of those 30s will neutralize the 90s and I'll get more data that looks like it's coming out at that mean is a 60-second point. And again, that kind of creates that flat line we were talking about that may not be perfect like we see here, but it's close enough to being a flat line that you can visualize it, or you can use math to look for deviations off of the mean to see, hey, all of these hours are close enough together that there's persistency here. This is something we need to worry about. We have actually got about 28 different patents on the way we do beacon detection. What's the back end math look like type of thing. And that is in RETA as well as the commercial product. And the only reason we really patent it is to make sure somebody else didn't patent it and say, you can't use this anymore. RETA's open source, so anybody can go off and use it. Connection time deltas with no jitter. So this is what I was talking about earlier. It's always going off at a 1 second interval. So most of the time when you see a beacon that's not evil, it's going to kind of look like this. It's going to be going off at that same time interval all the time. But if it's varying the timing, like you see here, that's usually an indicator that 89% chance that this is going to turn out to be evil. Well, what's that other 1%, Chris? The 1% that I've run into is cloud vendors checking status on virtual machines. They jitter that connection timing so they don't run into a situation where all the VMs are trying to report in at the same time, and that would actually, flood the system. But that's a very unique use case, and it's very easy to figure out because you'll see it taking place with an IP address that's also part of your cloud provider's environment. So you don't run into it that often. Beyond that, yeah, when I see this or this, I know I'm going to have a bad day. Let's see. I'm the only one who doesn't know what Chris is talking about. So Abdullah, if you're not getting all of this first time through, that's okay. That's okay. Make note, the stuff the stuff that's making sense to you, absorb that, go with it, run with it. The stuff that doesn't, don't let yourself get frustrated because you can always come back and go through this again. So one of the things that's kind of cool about this class is we have repeat offenders. There's folks that as I see names go by on the screen, I've seen them in this class many, many times before. We actually have started handing out swag to folks that have attended this class 15 times or more. So for those of you in the audience where this may be the first time you're getting exposed to this type of content and you're saying, whoa, I'm picking up on some of it, not all of it, you're not alone. One of the things I love about threat hunting, this is new. This is cutting edge. This is you're like you're the tip of the spear if you're working in this stuff. But to me, that's friggin' awesome because it's not everybody's already got it all figured out. That stuff's boring. Like pen testing. Oh my God, how many times can you do a buffer overflow and think it's new? It's not. This is bleeding edge. So if there's some stuff here that's not automatically absorbing for you, do not sweat that at all. Just make some notes, come back, go through it again, and just know lots of others have done that as well. We've had over 30,000 people take this training. Individuals take this training. And out of those 30,000, many, many of them show up multiple times. So don't sweat it if you're not catching everything. What if I don't have a GUI? In other words, I said, this is a great way to figure out if I have connection persistency. But this is a GUI that's part of a tool that I may or may not have access to. Is there a way to kind of do this on the command line? Yeah, we'll get into this when we get into the labs. But this script here that you have, beacon T-Shark, and I put this here just in case you want to go play around with this, right? I'm not going to do this hands-on for now. But if you go into the lab 3 directory and you run this command, beacon-T-Shark, lab3.pcap, and then these 2 different IP addresses, what beacon T-Shark does is it reads in a PCAP, and then it takes a source and destination IP address as endpoints and counts how many times did that source connect to that destination each hour within that PCAP. So the first column is the number of times connection took place. The right-hand column is the hour of the day. So you can see it's not exact, but we're around 550, 560 connections every single hour. That's connection persistency. but it's not exactly 550 each hour. Notice 549, 557. Oh, that's jitter. So you don't actually need a GUI to figure this stuff out. Some hacky scripts. So Bill, and it's time for a break. We're going to take a break in just a second, but I got to get this out first. So Bill Stearns, who is in chat, and Bill is awesome, and a lot of this cool stuff we're going to be using is Bill's design. But Bill's official job title, yes, he can show you a business card if you want to see it within active countermeasures, is Master of Shitty Little Shell Scripts. And he likes to, kind of poke the fact that he writes shitty little shell scripts. It's horrible code. It's not, it's something that give developers nightmares. My scripts are even worse than Bill's. So if you actually go look at this beacon-t-shark script, it is a total hack job. But I kind of do that for a reason. I could improve on it if I wanted to, but then you wouldn't get to look at it and say, I could do that. Yeah, you could. And you may come up with other ways to adopt it and have cool things happen. So when we get into tools, one of the things I'll talk about is like writing your own scripts, simple scripts. Sometimes is some of the best threat hunting tools out there. And with that said, it's top of the hour. Let's take a break. At 10 minutes after the top of the hour, we'll pick up from here and keep going. I'll catch you then. I'm going to be on mute during that time. All right. We are back. I'm going to apologize up front. I mentioned during pre-show that I've rewritten a lot of this class. Yeah, I rewrote over half of it. During the day, my job is to make sure other people can do their job, which means the time I have to do my job is at night after everybody else goes to sleep. So most of the stuff was developed at 2, 3 o'clock in the morning. So a couple of folks said that they ran this and they only got one line of output and it wasn't right. And I'm looking at it and I'm like, what the heck's going on there? And I figured out what it was and I figured out how to fix it. So let me show you that. So the first thing, so we're going to go hands-on real quick. So the first thing we're going to do is figure out what IP address are we using on our VM. And this is going to be a little small typing. So let me type it into chat first, the command I'm going to run, just so everybody else has it as well. There we go. So I just put this into chat. So the command is IP space the letter A, and then pipe that through rep-w inet. And when I do that, I can see that my IP, I've got a couple IP addresses listed. The first one, the interface is LO, that's the loopback interface. The second one, ENS33, that's my actual network interface. So 192.168.149.133, that is the IP address of my VM. Great. Let me get this out of the way, and then I'm going to pull up my Windows command prompt, because that way everybody can follow along with what I'm doing. No, that's not my Windows command prompt. Come on. There it is. There it is. And here's what I'm going to do. I'm going to say SSH space the login name I'm using. So that's student, STUDENT, at, and then the IP address that was assigned to my VM, 192.168.147, 133. And that's it. That's all I need. I'm going to run that command, and it's going to pop up. I get something wrong here. Oh, I got the IP address wrong. It's actually 149.133. Oh, come on. Don't make a liar out of me. There we go. I'm not sure why that took so long to give me a password prompt, but password I want to use is find, FIND, C2, all one word. Great. Now, I'm going to go into the bin directory. So I'm going to say CD space. Actually, let's take a look at where we are here. So here's all the directories and files that are in our home directory on this Linux system. So there's a couple of interesting ones here. There is the bin directory. This has got a couple of the scripts that I've created in it. And then here's all the lab directories that we're going to be using to do labs later on. So let's start off in the bin directory. So I'm going to say cd space bin. Now, if I type LL again, that lists out all my files that are in here. And we want to edit this file here, beacon-tshark. That was the one that I just gave you as an example on this slide where you were getting different output than I was. Now, if you're familiar with the Linux command line, use the text editor your choice. I'm a VI dude from way back, so I like using VI. But VI isn't easy to learn initially. So what I'm going to do is I'm going to use Nano. So if you've never edited files on a Linux system before, follow along with what I'm going to do here and just type Nano, N-A-N-O. And then I'm going to type B-E and hit my tab key. And that's going to complete the word beacon dash. And then I'm going to type TS. It'll give me the full unique name I want to edit, named Beacon Tshark. Once you get that, now you can go through and you can hit enter on that. Come on. This is being so slow. I think I got too many VMs running. I'll deal with that next hour. I'll deal with that the next break. Okay, so we've opened up this script file, and it's got some information at the top to kind of tell you what it is and how it works. But here's the problem. So I want you to use your arrow keys to navigate down to the tshark command, and then use the right arrow to scroll yourself all the way over until you get to this cut command, C-U-T. And it's going to say -D. It's going to have a couple single quotes with a space in the middle, -F. And you're going to see the number 5 listed here. It'll say -F5. What I want you to do is hit the delete key and then type in the number 4 instead. That's the only change you need to do. Once you do that, so some folks are saying, hey, I'm only seeing 172. So if you're on VirtualBox, you actually have to set up port forwarding to be able to SSH to it. And I got a couple of slides on that, including a link to a blog entry that'll walk you through the whole thing at the beginning of the slide deck. I'm on VMware. So if you're on VMware, this should follow along. If you're on VMware and you're getting a different IP address, that's okay. Part of the reason why I did that IP space A, right, pipe it through grep, was to see what IP address I have. If you have a different one associated with your network interface, that's okay. Just go ahead and use that one instead. So I've changed the 5 to a 4. Now down the bottom here are all of my functions. And what I want to do is I want to write out this change that I just made. I want to save it. So the command for that is to hold down the control key and then hit the letter O. So I'm going to do that. And when I do, it's going to say, hey, do you want to overwrite the existing file or do you want to change the file name? And we're just going to hit enter so it'll overwrite that file. Once it does that, hit Control X, and we should be back to our main screen. Now I'm going to say cd // lab3 to go into the lab3 directory. And then I'm going to type the command that was in that slide. And if the demo gods are looking favorably at me today, this time it will actually work. So I'm saying beacon-tshark. That's the name of our script. What file do you want to process? Well, in this directory, the only file in there is the lab3 .pcap file. So I just hit the letter L and hit tab to do autocomplete on that. Then I need to identify what IP address pair do I want to scrutinize, starting with the source IP. Well, the source was 192.100.136. The destination IP was 172.208.51.75. And now when I hit enter on that, here's our output. So what went wrong? What went wrong was that cut command is supposed to remove the hour field from the output, right? I go through and I have tshark print out hours, minutes, seconds for each of the timestamps. And then I go through and I try to cut out the hour. And for some reason, it was cutting out the wrong field. And that's why the output didn't look the way it was supposed to be looking. So we said, instead of cutting out field 5, cut out field 4. 4 was the correct field. And that went through and that fixed the output on this whole thing. Now, if I didn't know that, right? So let's say I didn't write this script. Somebody else wrote the script and it doesn't seem to be working for me. What do I do? Well, first thing I would do is I would go take a look at the script, right? Here's our script here. And I'd say, yeah, what's that doing? I don't know. Hey, I know. Let me run this command and I'll cut off the end of it and see what comes out for output. And then I'll cut out before that and see what comes out for output. So in other words, I'll kind of work through each section of the command to try to figure out what was that section actually trying to accomplish. And that may help you kind of troubleshoot things sometimes too. So yeah, bug in the slides. Sorry about that. Make that change. You should be able to get that same output that was here. So far we've talked about beacons based on session size, but it's actually possible to do, based on timing, but it's actually possible to do beacon detection based on session size as well. And the most accurate way to do beacon detection is to actually use a combination of the two. Look at them both. We talked about how that compromised system is calling home and saying, hey, do you have anything for me to do? And a majority of the time, what it's going to hear back is, nope, I got nothing for you. Go back to sleep. That's what's referred to as the heartbeat. There's a command set that's associated with that, and there'll be different command sets for different C2 channels. But what's important is it's asking the same question and getting the same answer each time, which means those session sizes will all be the same size. If we see a variation off of the session size, that's usually an indication of activation, meaning it called in and said, hey, do you have anything for me to do? And instead of the answer being no, the answer was yes. And whatever it was told to do is what resulted in a larger data transfer taking place. What's cool about this is we don't need to see payload. One of the biggest challenges we see is everybody wants to set up these intercept proxies and your TLS sessions. And, honestly, it doesn't work. Attackers have gotten really savvy. They encrypt their data and then they put it in a TLS session. So that super expensive intercept proxy you spend a crap load of money for and continue to pay a crap load of money for each year that tells you, oh, we decode all the traffic going by and go looking for malware stuff inside of it. They're stripping off the TLS session, and what's inside is ciphertext because the payloads are still encrypted. And then they're trying to match against it, which they never will because it's encrypted. They're pretty damn useless in a modern environment today. They're probably useful 15 years ago. They're not useful anymore. So we can't really count on being able to decrypt things, but we can use the sizes as a ballpark. So for example, one of the things I've picked up on from experience is if I'm seeing a lot of slightly larger sizes taking place down here, right? Like, here's my heartbeat. Here's my, do you have anything for me to do? No, go back to sleep. But then I see a bunch of slightly larger file sizes taking place. That's usually an indication that somebody's doing password guessing. In other words, they're saying, hey, let me try the password money against all the accounts in your environment. Let me try the password summer 2024 against all the accounts in your environment. They're doing something like that. That'll be small, jabbery little traffic like that. What if I've got a 1 gig database on this system and my boss asked me, hey, did they get the database? Well, did I get a 1 gig transfer? Hey, let me take that database and zip it up. How big is it? 500 megs? Okay, do I have a 500 meg transfer in here? Because if I do, I may have lost that database. If I don't, no, they didn't get the database yet. They may have looked at a couple of fields, but they didn't actually make a copy of it yet. Get them out now. We can get them out before things get really bad and they get a copy of that database. So session size can not only help you figure out if it's a beacon or not, it can also help you figure out, did the attacker activate the C2 session? And if they did, what they may have been doing once they got access to that system. So this activity, just so I understand, is an indication of C2 beaconing, or is this normal traffic? Good question, Zach. So this is, to me, is beaconing. The left-hand column is how many times that source IP address connected to that destination IP address. The right-hand column is the hour of the day. So what this is based, so let's put this in the context of we just grabbed this stuff, right? So what this would be telling me was between noon and 1 o'clock yesterday, 499 connections took place. Between 1 and 2 o'clock yesterday, 555 connections took place, and so on, and so on, and so on. In other words, my source is repeatedly connecting to the target a bunch of times every single hour. That's persistency. That is, if you see this, it doesn't immediately mean it's evil, but it means that there needs to be a very valid business case for it, right? Like, is it checking for time? Is it checking for patches? Well, none of those two make sense, right? Why would you check time 500 times an hour? Why would you check for patches 500 times an hour? Neither one of those situations makes sense here. So it's probably not going to turn out to be something like that. But I would still do the investigation work just to make sure there's no business related to it. But this to me is an indication of persistence, which would be an indication that they need to do further investigation work on why this connectivity is taking place. So that's what that means. Safe listing. So we're going to go through, we're going to hunt our network, and we'll find things that are connection persistency, but there's a legitimate business need for it. We don't want to run across the same things every day, right? So safe list is just simply, hey, we threat hunted this in the past. We decided this was not a threat to our environment. So we're going to remove this from future threat hunts going forward so that we don't have to pay attention to them anymore. That's what safe listing is for. And what's kind of cool about this is it causes these logarithmic improvements in your threat hunting. So in other words, let's say, I've got 1,000 nodes on my network, just throwing out a round number. And to go through and hunt my network for the first time, I collect up 24 hours worth of data, 24 hours worth of Zeek logs. I go in and I do a threat hunt, and it takes me 2.5 days to run everything down. 2.5 days of everything to run down everything that looks really interesting and go in and create safe list entries for it. Well, the next time I do a threat hunt, it's probably going to only take me a day because I safe listed a lot of the stuff that was on my network already. So I don't even have to pay attention to that. But I may find new stuff that I didn't have time to get to before that I might investigate now. That's why it's taking a day. But I've gone from it taking 2.5 days to it taking a day the second time. And the third time I do it, it'll probably take 4 hours. The next time after that, an hour or two. Next time after that, probably less than an hour. You get the idea. It almost accelerates itself each time if I'm leveraging the safe listing process. So part of identifying business need, do you recognize the domain? Microsoft, Windows, NTP, et cetera. So if I see somebody's trying to go to a host within the Microsoft.com domain and I'm running Windows systems, it's probably going to turn out to be something Windows related that's non-threatening. Not positively, we want to do the investigation work, but yeah, I'd lean that way initially, so to speak. If you can't figure it out based on the fully qualified domain name, okay, now it's time to start running stuff down. Like, let's say I see a connection to an IP address and I don't have any DNS information associated with that. What can I do? Well, what autonomous system number is it part of? That may help me figure out which part of the internet is it on. Like if I'm a K through 12 school and somebody's connecting to me from Quanzhou, China, that's probably going to turn out to not, or my system's beaconing out to Quanzhou, China, that's probably not going to turn out to be legitimate, right? I'm K through 12. I'm a local school. I expect local people to be connecting to me. I might occasionally have a parent who's traveling connect to the web portal to check on their kids' grades or something along those lines. But a majority of the time, it's all going to just be local stuff. So that geolocation information can help me figure out, is this something I need to be concerned about or not? Is there a PTR record associated with that system? That may help me figure it out. Geolocation data, you get the idea. There's websites out there like VirusTotal that collects statistical data on systems and whether malicious activity has been seen in the past. Investigating these IPs through sites like that may help. Can Beacon use a VPN as well? Yeah, you could run a Beacon through a VPN. And let's say an attacker, so if I saw so let's say the compromised system is creating a VPN to someplace out on the internet, and it's beaconing through that VPN, I won't see the beacon. Well, I would see the beacon actually, because it's inside a VPN, but VPNs only transmit traffic when there's traffic to be transmitted. And that beacon's going to be going off once per minute. So I may not see that, the eventual target it might actually it tends to get to, but I'm going to see a repetitive pattern in those transmissions most likely. Further, that is going to end up showing up as a long connection. So now I got to look at that and say, hey, my internal system, it's, speaking IPsec, or it's, got a TLS session running to a host out on the internet all the time. And that's a known public VPN server. Why is it doing that? Is there a business need for that? So, trying to use a VPN to obfuscate this probably isn't going to be that helpful. To a persistent blue teamer that's going to run down all this curious stuff that they run into. Good question. How does Tor network work in this beaconing equation? It really doesn't. Tor is designed for I'm going to tunnel my web browser traffic out. It usually isn't going to take care of other applications. That would be more along the lines of like a VPN. But even then, like I said, what you're going to see is some level of connection persistency going to whatever the VPN endpoint is. And now you'd base your investigation based on that. So I mentioned VirusTotal. There's actually a bunch of different sites out on the internet you can use to research IPs. Here's a list of them here. Okay. So we've looked for connection persistency. We've investigated the endpoint to see, is this something that looks like there's a business need associated with it or not? And I haven't been able to come up with a definitive decision as to whether this is evil or not yet. What do I do next? The next thing I always do is I go in and I take a look at the protocol and the protocol usage. What's nice about using Zeek for this is Zeek is actually application aware. One of the things that always burned my britches with firewalls, especially packet filtering firewalls, is that they lie to you. They'll tell you, oh, hey, this user was talking to that server via HTTP. And 99% of the time, if it's a packet filtering firewall, it's lying to you. It doesn't actually know where they're speaking HTTP to that server. What they're saying is they're talking to TCP port 80, but to be helpful, since TCP 80 is the well-known port for HTTP, I'm going to print it out as being an HTTP session. And that could be wrong. One of the things that I worked in an environment at one time where they tried to, strictly control what you go to on the internet and all that other crap. And one of the things they didn't permit was SSH. They didn't want to let you SSH out. So what I did is I set up my home system to have SSH listen on TCP port 443. Well, 443 is the default port for HTTPS, encrypted web traffic. So I would SSH back to my server, and that way I could tunnel all of my traffic through that SSH session. That's a whole other class we could do if you wanted to get into SSH. SSH does some really cool stuff like that. It can actually be, and if you want it to be, but and actually my architecture class, my network architecture class, I talk a lot about SSH and how to configure stuff like this. But yeah, the firewall would see my outbound session, but the firewall would label it as an HTTPS session because it was going to the well-known port for HTTPS. And the people who were in the firewall at that place didn't know enough to be able to say, well, let me look at the traffic and make sure it's actually HTTPS. And even if they did, SSH is encrypted. So unless you catch the initial banners going by that have the words SSH in them, it looks like encrypted traffic. It must be TLS. They can't tell the difference type of thing. So how would you register for the SSH class? So I created a class called Network Architecture, and I tossed it up through Antisyphon. I don't know if they're actually running that class yet or not. I would hope so. I wrote it like 6 months ago, but they've got a kind of a backlog of classes they're trying to get out. If that's interesting, if like learning about SSH tunneling and stuff like that is interesting to you, just do a post in Discord chat saying, would love to learn more about SSH. And Bill and I can do some blog posts on that. Bill has forgotten more about SSH and how it works than I will ever know. He is absolutely the guru. Good. We're seeing a lot of people getting that. Okay, Bill. So you and I have some blog posts to put up there. Um, so, so go back in time, and SSH didn't have an easy way for you to push your SSH keys out to a remote system. So if you wanted to use public-private key authentication, the way to do that is to put your public key out on every system that you want to be able to get control of. And back then you had to use secure copy to move it up and set the permissions and put it in the right directory, and it was a pain in the ass. And Bill wrote this tool. I think it was called SSH Keygen. Bill, correct me in Discord if I'm wrong there. But Bill wrote this tool that would connect to the SSH server, generate a public key that it could then deposit on that server, and it would put it in the right place and would do all this stuff. And I remember looking at the script that Bill wrote and realized he was using Netcat for this. In other words, Bill wasn't using an SSH client to talk to an SSH server. No, no, no. That's too normal. That's what most people would do. Bill used Netcat, a raw socket tool where if you don't understand exactly how SSH needs to negotiate its sessions, you're not going to be able to emulate an SSH session. He used Netcat instead in order to be able to make all this stuff work. So yeah, Bill knows his stuff when it comes to SSH. But I saw enough posts in there. Okay, so Bill, you and I, let's plan on doing a couple SSH and port forwarding and reverse tunnels and all that other fun stuff. I think folks will have fun with that. But Zeek understands the application layer. So in a Zeek environment, if I tried to SSH to TCP 443, Zeek would record that as going to TCP 443, but it would label it as being SSH. And now, who's ever analyzing the logs will look at that and say, why is someone SSHing to port 443? That's odd. That may be something I need to go in and find, do some investigation work on. So here's an example of what the output may look like. We'll look a lot more at Zeek logs later, so don't get too caught up in this. But I've got my source IP address, my destination IP address, my target IP. Now notice here it's saying TCP/80 and it's HTTP. Here it's saying TCP/80 dash. Why is it saying dash? It's saying dash because it didn't actually see an HTTP header as part of that session. And in fact, if you look at the amount of data that was transferred, for where it labeled HTTP, you can see it's like 400 plus bytes because an HTTP header went by. Here it's saying there was only 40 bytes that was transmitted. Well, that's my TCP and my IP header, right? My IP header is 20 bytes in size. My TCP header is anywhere from 20 bytes to 62 bytes. So 64 bytes. So that's just a packet with an IP TCP header, and then the receiving system just ignored it. And that's basically it, or it responded back and with a reset packet that said, hey, sorry, I don't offer that service. So since an HTTP header never went by, that's why Zeek is going in and labeling this as a dash. So being able to see what's going on at the app layer, super, super helpful. So having tools that actually decode the app layer and show you what's going by there can be really helpful. If I see a connection's going to port, 5555, if I can at least see what protocol is being used there as well, that may help me run down what's actually using that port. Unexpected protocol usage. So what I mean by that is exactly that example I gave. It's the well-known port for HTTPS, but someone's SSHing to it. Well, that's not normal, right? It's not breaking any RFCs. That's perfectly legal to do, but it's not normal. And those abnormalities sometimes can lead to some really interesting finds. So that's the type of thing, you'd want to go in and run down. So I mentioned this a little bit earlier. So we talked about beacons can get transmitted out to the C2 server directly. They can get relayed through a content delivery network. But the challenge with both of those is there's additional packets now leaving that system that someone might pick up on. Is there a way you won't see any additional traffic leaving that system? And actually, yeah, there is. So one of the things I can do is I can tunnel my command and control channel over DNS. Let's talk about how this works. This is one where it doesn't break any DNS rules. It doesn't break the ROCs, but it definitely bends them. You know, it's kind of like Neo in the dojo scene. Some of the rules can be broken, some of the rules can be bent. Your job is to kind of learn which is which. This is one of the ones where they're bending the rules. So the attacker decides they want to compromise the system and they want to use DNS to transfer the command and control channel. So they go out and they register a domain. Whatever it is, doesn't matter. And we're going to use the example evil.com just because it's easy to use. So they go out and they register evil.com. And as part of registering a domain, you're asked, hey, what are your authoritative name servers? Well, they point the authoritative name server addresses at the command and control servers. So these C2 servers are kind of special in that they listen on the DNS ports. They kind of act a little bit like DNS servers. So you can go in and you can actually set them up as the authoritative name servers for that domain. So now what happens is the compromised system, anytime it needs to talk back to the attacker, it'll do a query for some host within that domain. Well, it doesn't send that out directly. It sends that to whatever server it uses all the time for DNS queries. So the only new traffic leaving this system is DNS queries going to the local resolver. Well, that's not all that suspicious, right? Most environments aren't even going to notice that. So this gets to the resolver. The resolver says, I don't have this in my cache. Hey, let me go out to the root name servers. Okay, they sent me to the .com servers. Okay, the .com servers sent me here. Hey, server that's authoritative for evil.com, I need a text record or an A record or whatever for this fully qualified domain name. Well, this is coded to let the command and control server know which command and controls, which compromised system is calling home. And the answer is going to identify any commands that the attacker wants to go through and run that system. Further DNS queries later will be exfiltrations of data that might have been retrieved. So, for example, the attacker might say, hey, the next time that compromised system checks in, tell it to run the dir command in the Windows directory. So I want to do dir space C:\Windows. So now when this thing does a DNS query, the answer that comes back is that in an encoded format. And now the queries that come back out later is that same information, is the contents of that directory all encoded into the host parameter. So how do you catch this? Well, this doesn't break any DNS rules, but it bends them, like we said. What does it bend? Well, think about how many fully qualified domain names does it make sense for your average domain to expose to the internet? That number is pretty small, right? Like think about your average environment. You're going to have a web server, a mail server, a couple of DNS servers, maybe a customer portal, a DKIM record. Look, we're still counting on two hands. We haven't even made it to 10 yet, and that covers all the resources needed by most environments. So for most unknown domains, that number is going to be pretty small. But there are some internet properties out there that do a lot of online services that you may actually resolve a couple of hundred resource records within that domain on a daily basis. But the nice thing about it is they're well-known names. I don't have to tell you who Amazon is. I don't have Soft is, So you might actually see a couple hundred after them. So one of the things we can go in and we can look at is we can say, how many unique resource records are being resolved? And do I recognize the domain that's associated with that? So here what's going on is it's saying, hey, for the domain r-1x.com, this is the total number of queries we made. And honestly, we don't care about that number at all. Big number just means it was busy. That doesn't tell us anything. What we care about is this number. How many unique resource records, different ones, were looked up in the course of the same day? If you looked up www.google.com 1,000 times, that only counts as one. That's only one resource record. The fact that you looked it up multiple times over and over again, don't care about that. I care about, one query for www.google.com. Well, in this environment, r-1x.com, we looked up more than 62,000 unique resource records. Well, that makes no sense. I've never heard of that domain before. Why would my users need to access so many resources in that domain? It makes absolutely no sense to me at all. More than likely, that could be because it's actually a command and control channel, because the command and control channel changes what's actually being queried for a resource record every single time. The other thing you can look at is utilization. So let's take a normal domain. So Akka DNS is part of Akamai. We looked up 125 resource records. So again, largest content delivery network in the world. The fact that we looked up, 125 CDN servers doesn't really surprise me. But if I look over here on the right, what this is telling me is I had 3 servers doing queries for resource records in that domain. Okay, if those are my 3 resolvers, that makes perfect sense. And that resulted in 13 of my internal systems doing multiple connections to one or more of those 125 resource records. Well, that's how we expect DNS to work, right? User types in a name, DNS resolves that to an IP address, and then that system connects to that IP address a resource within that domain. This is how we expect things to work. Well, if I go back to the suspicious one, I can see that there's one system doing DNS lookups, but in 1 versus 3, that doesn't really matter. What matters is the DNS server is the only thing accessing resources in that domain. In other words, we looked up 62,000 plus resource records, but none of my users needed to access a single resource within that domain. That doesn't make any sense. Now, it's RFC compliant. There's nothing wrong with it from an RFC perspective, but that is very abnormal behavior. That's something that's worth going in and paying attention to. User agent strings can sometimes kind of tip us off on things as well. We'll actually work with one similar to it when we get into doing our labs today. But what this script is doing is it's looking at the http.log file that was created by Zeek, and it's extracting out the user agent string, and it's looking to see how many different IP addresses was this user agent used to talk when it was talking to. So in other words, how many different, when I use the user agent string A, how many different IPs did I talk to? When I use the user agent string B, how many different ones did I talk to? And I want to see am I finding a situation where maybe something is unique? So for example, here, I can see I talked to 15 different systems using this user agent string, which is associated with Windows 10. I talked to 12 other IP addresses with this user agent string, which is also associated with Windows 10. But there was one system out on the internet that when the same system was talking to it, look at this, Windows NT 5.2. That's Windows XP. So I'm usually a Windows 10 system, but I'm Windows XP just for this one connection? Yeah, I don't think so. Well, maybe they're running Windows XP in a VM, Chris. Yeah, that's possible. But how likely is that? How often do you see that taking place? And usually when you're doing that, it's because you're running some outdated, specialized accounting software, manufacturing software, something that's very specific and unique that they haven't bothered to update in a very long time. And yeah, that's when you're going to be running a VM to talk to that system. But that system is going to be on your network as well. It's not going to be hanging out on the internet someplace. So the fact that we change personalities and try to pretend to be Windows XP when we talk to one specific system, oh, that's a red flag for me. I need to go back and take a look at what's going on with those communication sessions. And you can do the same thing with TLS sessions. It's just instead of looking at the user agent string, we use something called a JA3 hash. The JA3 hash is just simply a hash of the SSL client hello that always gets sent first as part of a SSL or TLS session. So we simply hash that negotiation, and that's usually pretty consistent coming from that system. Okay, so we've looked at the protocol. Next, we need to turn our attention to the internal system, but we said don't cross that active passive line, so we don't want to go hands-on keyboard. So it'd be nice to have some sort of tools available, like, if you're in an environment where you don't have a whole lot of money and you can't afford something like Carbon Black, there's a ton of really cool projects out there. We maintain one called Beaker. Velociraptor is awesome. And again, it's open source. Anybody can use it. So having something collecting some telemetry off of your endpoints that you can go in and do things like, hey, I'm seeing a persistent connection. What application is causing that persistent connection to take place? Having an answer to that question can like solve an awful lot of the problems that you might run into. So leveraging internal host logging, you need to have something. You need to be collecting something from these endpoints. And like I said, we maintain a tool called Beaker. What Beaker does is Beaker uses Sysmon's the Sysmon utility. So this is a Microsoft tool that comes out of the sysinternals group. Sysmon can be used to collect all sorts of data. But the only thing we use it for is to collect ID3s. ID3s are applications talking on the network. So this could be an application holding open a listening port, waiting for inbound connections, or it could be an application talking to remote systems, making outbound connections like your web browser. But logging that, now when I see something suspicious taking place on the network, this is going to allow me to map that back to the application that's actually making those connections. That is huge. That is absolutely huge because that can allow me to resolve an awful lot that's going on. Like here, hey, I've got this system talking to this host out on the internet persistently all day long, and it's Notepad making that connection. No, Notepad doesn't talk on the network. No, the Notepad that we think it is, or the Notepad that we know and love, does not make network connections. It's not going to be calling out to a non-Microsoft IP address all day long. No, does not happen. This is not the Notepad we think it is. This has got to be something else. But I have no system logs. Like I said, Beaker, Velociraptor, there's a lot of decent open source options out there for you. So what's next? Well, we've kind of come to the end of our network threat hunt to where we're at the point where we need to be able to say, I'm pretty sure this is safe, so let's add it to our safe list. Or I'm pretty sure it's compromised. We need to go in incident response mode. Or I don't have enough data yet. I need to come up with a new test that's going to help me definitively decide, is it safe or is it not? I want to be able to do one or the other. And as we said, everything we do as threat hunters shouldn't leave any footprints. It shouldn't leave any evidence that an attacker might pick up on. I've seen this. I've been in environments where, they had it set up so that when a system was detected as compromised, they could go into the switch and isolate it off onto its own little isolated VLAN. And it sounds like a great idea, right? Oh, it's compromised, isolate it off on its VLAN. Here was the problem. The attacker didn't own just that one system. They owned about 12 or 14 others. The problem was the system they detected, that was calling out once every 30 seconds. That system was being noisy as hell and they picked up on it. The other 12, 14 boxes, they were only calling home about every 6 to 8 hours. They were being really stealthy. So when they isolated the main system, that triggered one of those other systems that when it called home and said, hi, do you have anything for me to do? It was told, yeah, you're now the primary conduit into the environment. Drop your dwell time on your beacon to once per minute. And now the attacker comes in and starts saying, why can't I get to the system that I owned before? And if they can figure out that, hey, it's been isolated off of the network, now it's, well, geez, they're onto us. What do we do? And usually the answer to that is, let's go scorched earth. If they're going to try and take away our access to the systems that, we put a lot of effort into owning, we're gonna go scorched earth. If we can't own that system, nobody can. We're going to start burning things down as quickly as we can. So again, don't do anything the attacker can detect, even isolating it off. Anything they can pick up on before that happens, go in incident response mode. Get more people involved. Get a range of skill sets involved. You want network people, forensics people, host level people. You want everybody in the room so that when someone says, well, hey, let's just isolate it off on its own VLAN on a switch. That way it can't infect other systems, which on the surface sounds like a good idea. Hopefully there'll be one person in that room that says, no, stop. We need to get scope first. We need to know if anything else is owned because this is the bad thing that can happen if we don't. All right, let's talk a little bit about tools. So T-Shark. So most folks are familiar with Wireshark. Wireshark is a graphical based tool that you can use to go through and decode packets. And Wireshark's an awesome tool when you have a limited scope you're trying to investigate, right? Like you want to see a specific session, or you want to analyze all the connections between two specific IP addresses, something like that. Where Wireshark falls down is I have millions of connections taking place and I need to sort through it. The first problem you run into is Wireshark needs to load that whole thing into RAM first. Well, gee, let's do some math. I've got a system that has 8 gigs of RAM, and I want to try and read in a 50 gig PCAP. What's going to happen? 50 gigs doesn't fit into 8, with an operating system. So there's going to be a ton of swapping taking place. So it's going to run really slow. So what I like to do is, Wireshark is usually that last tool that I'll go talk with. But if I need similar functionality, I'll drop to the command line and use T-Shark. One of the things I love, love, love about T-Shark is I can go in and specify the fields I want to see. So rather than just getting a summary or getting everything, I can go in and I can use the -T field switch with Wireshark to say only print out these specific fields. So I can say -E this field, -E that field, whatever specific fields I want to say. In this case here, I only wanted to see, hey, what DNS queries are being made. And now, boom, all I see are the DNS queries that are taking place. And that's it. So this can really be helpful if you're trying to hunt through PCAPs. Today, I'll be honest, the first thing I usually do, import it into Zeek and process the stuff in Zeek. It just goes a whole lot faster. And if there's some answer I need that Zeek can't give me, now I'll go back and refer to that PCAP. Here I'm going in and I'm just extracting out the user agent field, and I'm sorting those out to see how commonly each one of those are being used. And there's a ton of different fields that I can choose from. 185,000 of them, to be specific. How do you find them? T-Shark space capital G is going to show you all the possibilities. But the problem is it's going to scroll past the top of the screen and it's going to be hard to read. So here's a little trick you can do. T-Shark space capital G, type that through the grep command, and then you say single quote /s, and then whatever it is you want to go in and search for. So if I want to look for HTTP filters, if I want to look for IP filters, if I want to look for filters that are associated with TTL or whatever, put in some form of a keyword, and then /period quote. And then here I'm just piping it through less to pause a page worth of output at the time. But that's a good way to be able to go through and search through these. There's Wireshark makes them available. There's a web page you can go through, but it's kind of clunky. I actually find this to be a whole lot faster. But Wireshark, like we said, this is a great tool when you have a limited scope to go through and do an evaluation for. You can do some really awesome things with this, like pull out statistics. You can follow streams with it. The one thing I will say is that a lot of its statistical analyses are done statically, and they're not always accurate. Zeek, I've mentioned a lot. This is probably one of my favorite tools, because it'll take every session that took place and summarize it down to a single line. And it'll store basic information about every connection into a file called con.log. And then it'll generate additional logs on top of that to store application-specific information. And it only generates those log files if it sees that data. So, for example, it won't create an SSL.log file unless it sees SSL or TLS traffic. It won't create an SSH.log file unless it sees SSH traffic. It won't create a DHCP.log file unless it sees, you guessed it, DHCP traffic. So that's a great way to go in and kind of get a handle on, very quickly on what's actually taking place on your network. Zeek usually prints things out in epoch format. What's nice about this is it's very granular, but it's kind of hard to read as a human, right? Like, oh, when did this packet go by? Well, I'd have to pull out a calculator and start doing some figuring to figure it out. One of the things you can do is you can use the -D switch. This works with Zcut, and we're going to be using a different tool called Zcutter And I'll talk about why in a little while, but that also supports that same -D switch. And that converts the timestamp field from this epoch format to something more human readable that's easier to go in and understand. So I mentioned we're going to be using zcutter. Why? So zcutter was written by Bill. Gee, there's a surprise. Bill creates all sorts of really awesome tools. But zcutter is just incredibly flexible. One of the challenges you run into with zcut is zcut will work if the Zeek logs are in CSV format. But Zeek supports an alternate format called JSON. And sometimes folks use that instead. So if you have Zeek logs in JSON format, you can't use zcut to review them at all. And that's kind of a bummer, but you can use zcutter. The other nice thing about zcutter is it can be a compressed file or an uncompressed file, and it'll read it. So normally with zcut, I would have to decompress the file and then process it using zcut. Zcutter will just take it in directly. So it's got some really good functionality to it. So we'll be using that when we get into doing the labs. And there's a ton of other tools out there. I mentioned Velociraptor. WAS is another one that gets you some really good endpoint information as well. There's some really good stuff out there to kind of help you figure out what's going on in your network. And the last one I want to hit, data mash. So data mash is a data processing tool. And it's a statistical tool. So it's designed to be able to go in and say, hey, for this range of numbers, what's the minimum, the maximum, the mean? That's really what it's kind of designed for. But data mash has another function to it that's really cool, which is it has the ability to add values in a column. I'll give you an example. So here I'm looking at Zeek's con.log file. And I'm extracting out the source IP address, the destination IP address, and how long did the conversation take place between those two systems. So I'm looking here for long connections. So for example, I can see 192.168.1.105, talk to this IP address here, but 328, almost 329 seconds. Great. Well, but wait, it also talked to it for 27 seconds here. Oh yeah. Hey, this IP address was talking to that IP address for 41 seconds, but then it did it again for 31 seconds. So you can see the problem here. I may want to add these up to see what the total cumulative time was, but how do I do that? The way I can do that is I can do it by running it through data mesh. So I'm telling data mesh here, when column 1 and column 2 are the same value, I want you to add up column 3 and only print out one line. So that allows me to combine, these two pointed at in red. So I'm printing out one line with the cumulative time as opposed to individual connect times instead, which can be super helpful. Now, a couple things. I got to sort the data first. Data mash won't go through and say, oh, I got an entry here, and then 3 lines later, I got another entry here. No. It needs to see these continuously, one after another. So I need to make sure I sort the data. So when the source and destination IP address are the same, all those lines are one after another. Otherwise, I'll get incorrect results. Also, data mash wants to work with numbers. It doesn't want to work with alphanumeric characters. It only wants to work with just numbers. So I need to remove, this is removing any blank lines that might exist in that file. And Zeek has a thing where if this IP address tries to connect to that IP address, but this IP address tells it, go away, I don't want to talk to you, it'll label the duration time as a dash. So it's saying, hey, it tried to connect, but they didn't really carry on a conversation with each other. Well, a dash is not a numeric value. So I also need to remove those. So that's what these grep commands are in here doing. So if you need, so where I'm going with this is if you ever get in a situation like this, where you need to add up columns of data, data mash could be a great tool for that. And with that said, let's take a break. So it's about 2 minutes after the top of the hour. So I'm going to say at 12 minutes after the top of the hour, we'll come back from break, pick up from here. I will be on mute until then. We are back. So just a reminder, if you have questions or something, please toss them into the Discord channel as opposed to the Zoom chat. There's a lot of things to kind of keep track of. And sometimes I neglect to even think about looking there. So you're far more likely to get a quick answer if you post it in Discord.
Chris,
All right. Yes.
hey, just quick. I think possibly with the people who didn't download the VM but set up their own, they may not have beacon-tshark and the beacon-simulator.sh you're about to cover. Can you upload those to ACM webcast content maybe on the next break?
Yeah, I'll try and find time for that.
Sounds great. Thanks much.
Just making some notes on this so I can fix the upload file so that it's there for everything. All right. So when we left, we were talking about, detecting beacons, which means that we want to have some processes in place to be able to go through and detect beacons. But we want a way to be able to go in and test those processes, right? We want to be able to go through and actually see, maybe create a beacon and say, does it get detected? Do we find it? I've seen some funny stories around this where like people are trying to use like signature based stuff to catch beacons. And, the threat hunting team will say, hey, we need better tools because we had a beacon running the last 3 days and it didn't flag any alerts. And the IDS team will say, oh, well, what was it? Oh, it was this connection pair here. Oh, we wrote a signature for it. We're fine now. We don't need better tools. We can detect that now. So then they go in and they just make a slight change how the beacon's working. And all of a sudden, yeah, it's getting missed again. And they go through that around and around until the second team finally gives up and says, okay, fine, let's get some better tools. So you need a way to be able to go in and simulate some beacons. There's a number of different ways you can go about doing that. One of them is yet another tool written by Bill Stearns. This one here, Beacon Simulator. What this allows you to do is the syntax is Beacon Simulator space where you want to send the traffic to space what port you want to hit, how often you want it to beacon, of jitter off of that beacon, right? So this is saying beacon every 300 seconds. And if I set this to 0, it would go off exactly 300. But by saying 10, it'll beacon somewhere randomly between 290 and 310 seconds. So it allows you to kind of jitter it back and forth. What I really love about this tool is that you can also jitter the payload anywhere between 0 and whatever number you define here, which here we defined as 5,000. What I like about this is we have not seen any attackers jittering their payload in the field. I'm not even seeing red teamers do it. Basically, at the end of the day, basically everybody's using Cobalt Strike. So until it gets added as a feature in Cobalt Strike, it's very rare to see otherwise. I mean, even nation state uses Cobalt Strike. So we haven't seen this yet. But my gut feeling is we may eventually see it because it's another way for them to try and obfuscate their traffic. So it may happen eventually. So this is already built into this tool. You can test to see, are you ready for that when that does actually start happening? But you can also create simple beacons just using some simple scripts. So this is a script that's in the bin directory named beacon-test, and this is what's included inside of it. So all this is a loop. This just says, hey, keep looping until somebody kills the process. And what it's doing is it's running the curl command. It's creating a user agent string of Atari 2600 Frogger browser. So, for the old schoolers, you may remember Atari 2600. That's the one that had the little cartridges. And there was a Frogger cartridge where you could play the Frogger game. It did not come with the web browser. But hey, new school folks may not realize that. So, but what I like about this is it's a unique string that you can then go in and match on without false positiving against anything else. You will not run across this user agent string in normal communications. Atari 2600, it's just not going to happen, right? So it allows us to go in and do some unique things. One, to see if anything triggers on it, but two, so that we can easily go in and find it if we've got lots and lots of traffic going by. And when I run beacon test, I specify a target IP address that I want to send this traffic to. The $1 is just acting as a variable to kind of pull that in. And then see this function here? Shuff is like random. only it's actually more random than random. And we're telling Chef, I want you to pick a number between, in this case here, 200 and 350. And I want to pick one number. So pick one number between 200 and 350. So let's say it picks 300, just to throw out a round number. This session will now sleep for 300 seconds. After the 300 seconds, it'll go back and run the curl command. And then it'll get to this line. It'll pick another random number between this range. So what I like about this is that the plus or minus percentage or value, that's how Cobalt Strike works. That's how all these tools work. That's what we're used to kind of going and looking at. But it is possible to truly randomize that jitter. And some tools may not do as well once you truly start randomizing the jitter. This allows you to go in and test that. And you can run this command from the command line, or as I did here, you can run it as a screen command. And now it's detached from the terminal. It's running in the background. You can exit out of your SSH session, come back later and reattach to the screen session if you want. That'll allow you to interact with this thing anytime you need to, but you don't have to leave your SSH session running all the time. HPing 3, way too extensive for me to get into. But if you wanted to get into things like, hey, I've got a certain payload I want to send, HPing will let you do that. And creating your own scripts is like one of the best ways to go through and solve a lot of these problems. We kind of get in the habit of, oh, I need to solve this problem. Let me go see if somebody created a tool. But sometimes it's just easier to write the tool yourself. And it's not always as hard as that may seem. Let me give you an example of that. So one of the other things you have on the VM is this FQ binary, or this FQ utility. So what the FQ script does is it looks in the current directory that you're in, and it looks for any DNS log files, and it extracts out the answer in the query. And then it searches to see if an IP address or a fully qualified domain name that you specified after typing FQ shows up in any of the DNS queries or any of the DNS answers. So, for example, when I ran it against this IP address, it came back and said, oh, yeah, somebody queried fw.adsafeprotect.com, and this was the answer that came back. So let's say I'm looking at a PCAP or I'm looking at a log or something, and I see a connection to an IP address. And I say, I wonder why the user went to that IP address. Well, I can type in FQW, and it'll check all the DNS logs to see what was looked up that returned that IP address. Now I know why they went to that IP. Now, I did it in the DNS.log file, but I also went looking for the host parameter and the user agent string to see if pattern matches on anything in there and spit that out if applicable. And I also looked at the SSL.log file, which is going to have my SSL and TLS traffic, to see if there's a match there. So for example, here it's telling me, yep, somebody did a DNS query for this, that returned that IP address, and someone did a TLS connection to that IP address. This was the SNI information. This is digital certificate, which matches that DNS, and the digital certificate checks out as being valid. So let's say I was looking at this and I'm saying, hey, is this really going to the system in AdSafe Protect? Or is it maybe a variation off of the name or somebody spoofing the traffic or something like that? Well, I can say I had a valid digital certificate that checks out. So, that's not 100% definitive, but it's 97, 98. It's better than just hoping for the best. And this is, as you can say, there's really 6 lines to this script. 3 of them are echo statements that just print out a header. The other 3 are just seek commands. Go through and cut out the data I want to go through and say. So again, pretty straightforward. We looked at beacon tshark in there earlier, but there's also a beacon-con file or a script that'll let you look for things within the con.log file. So for example, hey, I saw this connection pair and I wanted to see, does it look like a beacon? And it went through and checked it out. Here's the actual command it's using. So we're using zcutter here instead of zcut. I'm getting things updated to that. And then my $1, $2 is just simply the variables. So the way I would run this is I'd say beacon-con space first IP address, second IP address, And now I can see the number of connections that are taking place each of the hours that are inside of that Zeek log file. So that'll allow me to go through and look it up pretty quickly. And, there's a variation off of that that'll use the SNI information, the host parameter in the http.log file. I get a couple of different ones that are in there. All right. Is there a mailing list for new classes or places to look up future classes? Yeah, we actually have, if you go to acm.re, we have an events calendar. We post stuff up there. There's also a mailing list you can subscribe to, and we'll give you a heads up whenever new classes are coming out. All right, so now we're getting into the hands-on portion of this class. So for the next 3.5 hours, this is all hands-on stuff for you to play with. So hopefully you get your VM up and running at this point. Hopefully you're able to log into it. Hopefully you're connected and you're going. We've got a couple of different things we're going to do. The first is I refer to it as a walkthrough. So a walkthrough is I want to expose you to a tool that you may have never used in your life, but I don't want to just dump you into it and hope you figure it out. So what we're going to do is we're going to take a problem and we're going to go through and we're going to work on it together. So I'm going to go through and I'm going to do things on my screen, and I'm going to do it at a pace that allows you to go through and follow along on your screen so you can do the same thing. So that way your first experience to the tool isn't trying to figure out what's going on. And then I'm going to do it, and you just need to mimic my actions to get the tool to do the same thing for you. And that'll give you some initial hands-on experience with the tool. So, you start getting the warm fuzzies for it. And then after that, we'll do some labs. So with a lab, I'll give you a problem. I might say, hey, there's a critical connection pair in this data set. Tell me if it's evil or not. That's a lab, right? Now you need to analyze that and go through the different steps to figure out, is this something that could be safe listed, or is this something that might trigger incident response mode? Now, when I give you a lab, there'll be a slide that describes the goal of the lab. And the next slide after that, which I won't show you, is a hint slide. And what the hint slide is there for is, it's probably obvious we got a range of skills here, right? We got some folks that are like, hey, this is the first time I've ever done something like this. And, we've got other folks that I know I've seen them in this class at least 10 times. So we've got a range of skills. So how do you make labs that are challenging for the folks who've done it before, but not completely outright frustrating for the folks that have never done it before? Well, that's where hints come in. So if you look at the lab and you read the lab and you say, oh, yeah, okay, I kind of think I know what I need to do with that, go for it. Just drop and run, get it done. If you read it and you say, well, I understand what you're looking for, but I'm not even sure where to get started, that's what the hints are for. If you're in that second group, go ahead and look at the hints page. There's no shame in that at all. And look at some of the hints and see if that doesn't help you kind of get started off in the right direction. If you go through the hints and you're still confused, the next slides after that are going to have the answers. So you can look at the answers and kind of reverse engineer, how is that answering the question that was staged as part of the lab? Now, we're going to be working with Reader version 5. This is the latest version. If you worked with Reader before, this is totally different. We've made a ton of different changes to this. But we literally changed the back end, the front end, and the middleware. I mean, that's all. That's the whole software stack right there. So we've changed everything. Now, anytime you change everything, there's going to be some bugs that make it through QA. And I've actually run across a couple of minor bugs as part of that. And I will highlight those as we go through. Just keep in mind that all the bugs that we're going to talk about, I've already gone back to the devs. We've created some tickets. We're going to get this stuff fixed. These will be removed in later versions of of Rita. But Rita's new, so we're running into them now. So I already kind of walked through this with you already. I already kind of walked you through how do you find your IP address and how do you SSH to that system. So I talked about, login student, password find C2, and then run that grep-w inet command. And when you do, you'll see some output like this. What I'm looking at is the host interface names. right? LO tells me that's the loopback interface. The only thing that can talk to that is the local system. So that's not the one I want. This set is labeled as being Docker. This is labeled as being a bridge. Okay, those aren't things I can really SSH to talk to this VM. The only one that looks like a network interface that I can SSH to is this one right here, ENS33. So now I know, okay, whatever IP address is associated with that, which in this case here is 192.168.149.133, your IP might be different, and that's okay. Now, when I want to SSH to that system, that's the IP address I need to use. And when I did that earlier, you saw, the first thing I did was I went in and I used SSH just from the Windows command line. And I went in and just used it that way. And when I did, I said SSH space student at whatever IP address I saw here. And when I did that, it popped back up and said, hey, this is the first time you're connecting to that system. Here is the fingerprint for the private key of that system. Is this the key you expect to be on that box? And we're supposed to go through a manual process to validate this, which we're going to skip over because it's a VM running on a local machine. It's if someone has come in, launched a different VM, and they're doing a man in the middle and getting you to connect to that one instead, your biggest problem is not that you're connecting to a different VM. You've got other bigger problems going on with your host system right now, right? So we're going to skip that. And we're just going to say, yes, that fingerprint's fine. Don't worry about it. Password is fine C2. And then once you log in, you'll get a prompt kind of similar to this, although I nuked this section already. The whole unminimized thing, I just found that confused. That might confuse folks. So I nuked that out. So that'll be gone. But let's kind of do some poking around. So here's my Windows prompt. Expand this out a little bit. I'm going to go back to the home directory, clear things. So let me just kind of do a couple of things just to kind of poke around to see what's what. So I'm going to type pwd. And when I type that, that tells me I'm in the home directory for the student user. Great. That's where I expect it to be. If I type in the command ll, that'll list out all the files and directories and give me verbose information on them. So I can see I've got a bin directory. That's where my scripts are located. My lab 1 through 4 directory. Those are the directories I'm going to be working with for doing each of my labs. So this is where all this stuff is located. Let's see what else is kind of interesting or useful at this point here. If I go into that bin directory, type ll, there are all my script files. And I had shown you those a little bit earlier. But just to kind of poke around a little bit and kind of show you how to navigate. I did a cd space bin to get there. So now if I type in pwb, it's going to show me in one directory lower than the student home directory. Want to go back up, cd space ... to that. Want to go back down, let's go to cd space lab 1. And if I say ll, what's in that directory? There's just a pcap. So all of my lab directories are going to have a pcap in them, and that's it. That's the only thing that's going to be installed there. And if I need to navigate from one of the lab directories to the other, here's a little trick you may or may not already know. Instead of having to go up to the home directory of one command and back down again to, let's say, the lab 2 directory in a second command, I can type in cd space ... Well, it helps if I have the screen up. There we go. cd space ... lab 2. And when I do that, I immediately go up one directory, back down another. It's just a quicker way to be able to get over there from there. Now, Rita is installed on this system. So if I type in which Rita, that's going to show me where is the executable for Rita located. And it's under user local bin Rita. Zeek is also installed. So if I say which Zeek, it's going to show me the path to that. Now, the version of Zeek that gets installed with Rita is different from the regular version of Zeek. So if you've used Zeek before, you're probably used to what some of the command line switches are, and this is going to be totally different. And there's a reason for that. And the reason is we're using Docker. So if you type in Docker space images, IMAGES at the end, and hit enter, it says permission denied. Okay. So let's try sudo space Docker images. I thought I added it to the Docker group, but maybe I didn't. Another tweak I need to make to the VMs. So here are my Docker images. Notice I've got one for Rita, I've got two for Zeek, I've got one for ClickHouse, which is my database system, and I have one for my logging process. So in the past, Rita was something that got installed on the host system. Today, Rita container, and that Docker container simply gets launched on the host system when it's needed. And the nice thing about this is it makes it pretty portable. One of the challenges we ran into in the past, especially with trying to support Zeek and supporting at the backend database we were using Mongo, is that a new version of a platform might come out, right? Like Ubuntu 26 gets released, and they've made enough changes that everything breaks. So now we don't work on the newest platform anymore. So now we got to go in and make tweaks to make sure we work on that new platform, but continue to work on the old platforms that we were supporting. And it's a pain in the backside. Well, with Docker, all those problems go away because everything runs inside of a container. What do I mean by run inside of a container? Well, if I type in sudo docker ps, that's going to show me all my running containers. Succo. No, not succo. It's sudo docker ps. I have two containers running in the background right now. I have my logging process and my database process. The Rita one will launch as I need it. The Zeek ones will launch as I need it. But for the most part, they're not going to be there. So these are all running in Docker instances right now, which is kind of cool because so long as the next system I go to supports Docker, it'll support this as well. And in fact, one of the things we're kind of playing around with is with Windows, you can run the Windows subsystem for Linux, version 2, installs Ubuntu. Docker support Ubuntu supports Docker. You can actually, for the first time, get Reader and Zeek running on Windows within a side of a Docker container. We're not supporting that yet, but it opens up some really cool possibilities. So everything's running in Docker containers. So remember I mentioned that like our Zeek is different than the regular Zeek. So if we say which Zeek, it says it's under user local bin Zeek. So now I'm going to type less space, and I'm going to point it at that file. So I'm going to say user local bin Zeek, and we're going to take a look at what that Zeek file looks like. Well, you could see it's just a bash script. Normally, Zeek is a regular executable. Well, this is a bash script that was created by Bill with thanks to Logan and thanks to Ethan. Why is this a bash script? Well, it's a bash script because Reader and Zeek are running inside of containers. So what the script actually does is it interacts with that container. So the Zeek binary is in the Zeek container. So what our script does that you're interacting with is it reaches out, launches that container, reaches in that container and says, hey, Zeek, go do this thing for me. And then when it's done, it shuts the container back down again. Kind of cool. And like I said, so this allows me to do things like, run Zeek on Windows, which it's never done before, which is kind of cool. But that also means that the command line switches are different. So for example, if I just type in Zeek by itself, it says the switches I support are start, stop, read pcap, restart, status, reload, enable, or disable. And they say, well, wait a minute, Chris. No, read pcap. Zeek is Zeek dash lowercase r, and then the pcap name. No, not in our script. So things are going to be a little bit different. So for example, I can type in Zeek status, and that just comes back and tells me error response from daemon, no such container. That tells me Zeek is currently not running. So if I get an error, that means Zeek's not currently running in the background. And I don't need Zeek run in the background all the time unless I'm actually trying to go in and listen on an interface. Rita, same type of thing. So if I say Rita-H, notice what happened here. So when I ran the read command, it popped up and said, okay, let me check the status on these. I'm going to launch the read container, and now I'll run that command in there, and that command is going to list out what my valid switches are. So we're launching the container when we need it and then stopping it once we're done. So it's not actually there running all the time, but because it's in a container, again, that makes it a whole lot more portable than it used to be, which is kind of a cool thing. Now, the configuration for Rita is under the Etsy directory. So let me type this out, and then I'll throw it into Discord so that folks have it. It's under the Etsy Rita config, and it's config.hjson is what I'm looking for. Let me copy that. Like I said, I will throw that into Discord so you can just copy paste it. But when you run this command, that's going to open up that config file. And this is the config file that's responsible for running Rita and how Rita is going to go through and process data. I'm not sure why I got that little banner thing at the top. There we go. That cleared it. So I'm not going to go through every line in this config, but I'm just going to point out some of the things that are going on. Update check enabled, true. What the update check does is when you run Rita will come back to its GitHub repository. I think it's like once every 2 or 3 weeks, and say, what's the current version of Rita? And it will compare that version to whatever version it is and see if there's a newer version available. And if it is, it'll tell you. So that way you know if there's a new version available that you need to go through and pull down. If you want to use threat intel feeds, where do those need to get located? It kind of walks you through that. This is something that we're going to be playing with a little bit later, which is we can define different subnets for different reasons. So for example, we're defining our internal subnets. That way Zeek kind of knows what's inside versus outside, which helps with the data processing. I can go in and I can give it names or IPs of fully qualified domain names that I want to always include in things. This is the one we're going to come back and visit later, never include, which could be an IP address or fully qualified domain name. Remember we said one of the things that we're going to want to do is create safe lists. We're going to say, hey, I've run that down. I know that's safe. I don't want to pay attention to it anymore. Well, how do we add that safe list? Well, with Rita, we're simply going to come in and add these entries to these never include lines. And that's going to tell Rita, hey, anything that meets the specification, don't score it. Don't pay attention to it. So that way it's still there. It's still in the data, but we're just not going to go through and create a score for it. Now, if you really want to go down the rabbit hole on this stuff, and if you do, we would love it. The more people kind of playing around with this stuff, the better. And I just use the arrow key to kind of navigate down. I'm using the less command, so I can use page down, page up to kind of scroll through things. I can use the arrow keys. This is a parameter we're going to come back and visit a little bit later. Unique connection threshold 4. What does that mean? What that means is Reed is looking at how many connections need to take place in this 24-hour period of time before I'm going to evaluate if there's any beacon-like behavior here. And it's set for 4. So if a source connects to a destination 4 times or more in a day, we go through the math to figure out if it's a beacon or not. I think we dropped that value too low. With the old version of Rita, it was set to 20. And we didn't want to set it below 20 because we processing everything that fell between 4 and 20 added a lot more processing to Rita. It took longer to do because we didn't have as efficient of a database system. With the database system we have now, it's so much more efficient, so much faster that we said, well, yeah, let's drop this down to 4. Let's make it a really small number. I think we went too low. I think it's a little bit too sensitive. If, again, if you're a 3-letter government agency or your domain ends in .mil, 4 might be a good value for you to use. But for the rest of us, it might be a little bit low. So one of the labs we'll do later, we'll actually come in and try tweaking this up. We may go in and set it to like 12. Then we may go in and set it to like 20 and see what the difference is that comes about. That I think we need to bump that value back up a little bit is where I'm going with that. But there's all sorts of things about the way beacons get detected that I can go in and I can tweak here. I can go in and I can also tweak things for like long connections. When does a long connection considered to be a high severity item? Well, it's when it's been running for 12 hours or more. Maybe that should be 20. Maybe that value is a little bit too low. This is some of the things that now that we've got this new version of Rita that has all sorts of capabilities to it, we kind of went, let's make it super sensitive so we never miss a C2 channel. And now we're saying, okay, what can we back off to get rid of the stuff that's going to end up being business safe so that people don't have to go through that and, allow people to focus on the stuff that matters the most. So those are in the process of kind of getting tweaked through now. But this is the config file for Rita. So anytime you want to go through and make changes to the way that Rita's... What's that?
Oh, sorry, Chris.
That's okay. I think Bill thought I was his puppy for a second there.
Sorry about that.
No worries, dude. No worries at all. So one of the cool things about Rita is we've made it dead simple for you to go in and change the way we go through and do scoring. So if you want to kind of tweak how things are getting scored, you can do it yourself. And it's as simple as going in and just simply editing this text file. And that's it. That's all it takes. You don't have to go in and make changes to the backend code or anything along those lines there. Cool. So I'm going to hit the letter Q and I'm going to get out of this directory. And then I'm going to go to the lab 1 directory. So I'm currently in the lab 2 directory, right? So if I type in pwd, that tells me I'm in lab 2. So I'm going to say cd space .. lab 1. I want to go up 1 directory level, then back down to lab 1. So now that puts me into the lab 1 directory. And if I look what's in here, I got a PCAP in here. Now, we're not going to do this for every lab, but I would like you to get used to doing this because it's always good to kind of have a sanity check. If you don't know what the PCAP is that you're reviewing, you should look at it. I know all the PCAPs we process are 24 hours. Well, let me rephrase that. There are some 1-hour ones kicking around, but they always get clearly labeled as 1-hour PCAPs. The standard we use is 24 hours. So when I look at a PCAP, I expect it to be 24 hours. But hey, I gave you this PCAP. You don't know what it's there. So how do you figure out how long was this capture run for? Well, there's a command that ships with Wireshark and T-Shark called cap infos. Don't forget the S at the end, CAPINFOS, cap infos. And if I point that at a PCAP file, that'll give me all sorts of useful information about that PCAP file. It'll tell me, what file format is being used, the date timestamps, it was an Ethernet encapsulation, blah, 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 lots of stuff. But I usually don't care about all that stuff. Like what interface was this packet captured on? I don't know. I don't know what the system was. I don't care. I don't care that it used ETH1, right? That doesn't make any difference to me, but it might in other situations. So it's good to know that this tool can give you that information. What I do when I run cap info, so I just hit up arrow to retrieve the last command I typed. And I usually use the switches UAE. And when you use UAE, that goes through and says, hey, the lab1.pcap file, its total duration is 86,388 seconds. Well, 86,400 seconds is a full day. So we're just a little bit less than 12 seconds shy of a full day. So we've pretty much got a full 24-hour capture here. And it'll give me, the EA gives me the date, the start and stop time. When was it started? When was it stopped? So now I know I've got a full 24-hour PCAP to work with here. Cool. So I want to go through and do a threat hunt on this PCAP. Where do I start? Well, I could use T-Shark. I could use TCP dump. I could use something that reads that PCAP file. But we said Zeek makes this a whole lot easier. So let's convert this to Zeek logs. And then we'll say, hey, Rita, go look at those Zeek logs for me and see if you see any instances of connection persistency. Because anytime there's connection persistency, I'm going to want to go through and I'm going to want to run that down. So the steps are convert the PCAP to Zeek, have Rita import Zeek, and then go in and review the data inside of Rita. So the first thing we need to do is create Zeek logs. So I'm going to say Zeek, and the switch I use is read PCAP, READ PCAP, read PCAP. So now I need to tell it what PCAP do I want to read, and I need to give it the absolute path to that. I can't just say lab1.pcap. It's not happy with that. It wants a full path. So I'm going to say a tilde. A tilde is the reference to my home directory. So I'm logged in as student. So it's a reference to the student home directory. And then I'm going to say \lab1. Now I'm going to hit the tab key. And when I hit the tab key, you'll notice another slash shows up here. That tells me, yeah, okay, I specified the path to this directory correctly. And now if I hit tab again, it automatically fills in the name of that PCAP file because it's the only file in the directory. It's the only thing I could possibly want to be going through and adding in. So Zeek, read PCAP, full path to the PCAP, including the name of the PCAP. And then I need to tell it, where do I want to put my Zeek logs? Well, I'm going to put it in a tilde, lab1, same directory as this PCAP file. And that's it. So let me copy that just to make sure everybody's got it right. I'm going to throw this into Discord so that everybody has a copy of it too. And now I'm going to hit enter and let that run. So notice it started up the Zeek Docker container. It didn't bother starting up the Rita one because we didn't ask it to do anything with Rita yet. And then it said Zeek logs will be saved to the lab1 directory. So now I'm going to hit LL. And before the lab1 PCAP file was the only thing here, notice I got a bunch of other log files now. So con.log is the log file that has a summary of every connection that took place. And then the rest of these are based upon what type of traffic was being seen. So I got to break out of everything here, which is kind of nice. Now, what if I want to go in and view these logs? What if I want to go in and kind of check out what's inside of them? For that, I like to use the less command, but I use some interesting command line switches with it. Right? So let's do this. I'm going to say less, LESS space con.log. Try that. So type in that command, hit enter, and here's my problem. All of this is the first line of data. All of this is the second line of data. Everything's line wrapped. That makes it harder to read. So I'm going to hit the letter Q to quit out of this. And I'm going to hit my up arrow to pull back that last command. And I'm going to say dash capital S. I'm going to add that command line switch in. And then once I do that, now nothing's line wrapping. Well, wait, where'd all that data go, Chris? The data is off to the right. See how I've got little arrows here? That tells me, hey, there's more data off the right-hand side of the screen. So if I hit the right arrow on my keyboard, I can scroll all the way to the end. Now, here's the problem. My data, the number of spaces between my columns doesn't really jive with the titles. So like tunnel parent is this column. Response IP bytes is this column. Response packets is this column. Everything's way offset from each other. Is there any way I can get those to line up a little bit better? Yeah, a little bit. I'll never get it perfect, and I'll show you why in a second. But I can use the -X switch for that. -X allows me to specify how wide do I want those columns to always be. And I'm going to throw in the number 50 because I know that'll work. And I'm going to hit enter. Now notice my columns are much wider now. But my titles do a better job of lining up with each other. Now let's go to the end. Notice everything's off by 1, right? So my tunnel parent is here, response is here. I keep scrolling to the right, response packets is here. So my titles are still off by 1, but they're consistently off by 1. They don't get kind of mucked around because the spacing is different between the columns versus the titles. The reason everything's always off by 1 is because of this. They put pound fields at the beginning of the line. If they didn't do that, if they just said pound, and left it blank, or did pound TS for the timestamp field, which is his very first column, now everything would start lining up. It'd make life a whole lot easier. So, and then I'm going to hit Q to quit out of this. So this command here, and I'll throw it into Discord. That's what I was using. So if you need to go in and look at files that have all these columns to them, and everything kind of gets shifted around and it makes it hard to read, that's the best way to go through and do that. Now, so let's talk about what's actually in here. So this is my timestamp in epoch format. This is a unique Zeek ID associated with each of these individual sessions. This is my source IP address. This is my source port, destination IP address, destination port. What was the transport? What was the protocol being used? Notice most of these are HTTP, DNS, or we've got a few labeled SSL. Now, when you see SSL, it doesn't necessarily mean it's SSL. It could be TLS. They label them both the same. They both end up in the same file. But I can see how long did the connection run for. I can see, the number of bytes that was sent back and forth. I've got all sorts of general information that applies to every session, regardless of the application that's being used, right? Like number of packets, number of bytes, all of that's always going to apply. Now I've got all these other files that are specific to different types of sessions. So let's go in and I'm going to hit my up arrow and I'm going to hit my backspace. I'm going to change con.log to be HT, and then I'll hit the tab key, http.log. We'll just take a quick look at what's in here. So it starts off the same. I've got a source, I've got a timestamp, a UID number, source IP, source port, destination IP, destination port. But as I get over to the right, I get information that's specific to HTTP sessions only. So this is my method, so that this connection used a GET request. It didn't use a put. It didn't use head. It used a GET request for some information. Here was my my host parameter that was coded inside of the HTTP header. Here's the URI for the data that was being requested. Here's the refer field that was inside of that HTTP header. Here's the version of HTTP that was being used. So I have a lot of protocol-specific information in each of these log files that are associated with that. Pretty cool. So unfortunately, that's about as far down the rabbit hole I can go with Zeek and what's in the log files and stuff like that, just because we are limited on time. And I am noticing I'm a few slides behind on where I need to be right now. So we'll pick it up from here. But I do get into more detail than that when you get into the advanced class. But we've got our Zeek logs. So our next step was supposed to be import these logs into Rita. So I'm going to say Rita space import. I want to import some Zeek logs. So first thing I got to do is I got to tell Rita, what do you want to import? Because Rita will actually process more than just Zeek logs. I'm going to go in and say -L. I want to process Zeek logs. So I need to tell it, okay, where are those Zeek logs located? @ // you know where I'm going with this, right? 1, and then I hit the tab key. So that directory, that full path to that directory is where those Zeek logs are located. And now I need to say -D, what do you want to name the database inside of Rita? So I could give this any descriptive name that I wanted to. For the purposes of simplicity, I'm going to just name the dataset lab1 because this is the data that was in the PCAP that was in the lab1 directory. Makes it pretty straightforward. So I'm going to run that. And actually, let me throw that into Discord. So everybody's got that command. And now I'm going to hit enter. And notice it goes through, it starts up Rita, it does some processing, we get some nice little colorful bars, boom, it's done. So it went through and processed that data. So how do I know if it ran correctly? How do I know it actually did what I expected it to do? Well, one of my Rita commands is Rita list. List available data sets. Hey, that sounds helpful, right? So we're going to say Rita list. And then it's going to come back and show me, here are all the data sets that have been imported. I have one that's called lab1, and it is not a rolling data set. What's a rolling data set? A rolling data set is a data set that expects you to be continually appending new information to it. So if I had Zeke listening on the wire, every hour Zeke's going to write log files. Every hour I'm going to add that to read a data set. That's a rolling data set. So when something is a rolling data set, it knows add this hour to the end, delete the hour at the beginning. But we didn't want to create a rolling data set. We just wanted to say, hey, everything in the PCAP file process that. So that's what we went through and did. But I want to know, so what data did it create? For that, I'm going to type Rita space view. I want to view the data, lab one. Hit enter on that. And that's going to bring us to our new ASCII graphical interface. So in the past, Rita was a command line tool with multiple command line switches. There's multiple things to run. And so like if I wanted to see long connections, there was a switch for that. If I wanted to see HTTP-based beacons, there was a switch for that. If I wanted to see DNS, there's a different switch for that. So there's a bunch of different places I need to poke around in. This looks, with the new interface, everything shows up in one spot. Everything is right here. So I don't have to run multiple commands anymore. I mentioned we've got an ASCII graphical interface now. So this is based on Charm Bracelet Bubble Tea. Kind of a cool name. If the coloring is not right, and I can show you an example of that in the slides. And actually, that'll let me make sure I didn't miss anything. We looked at yeah, so all the stuff you just walked through with me, I gave you slides on it. So we used like Docker image and Docker PS. I made, we looked at Zeek, the executable, what is it? So we talked about all this stuff. Yeah, I hit that. I hit the help, the Rita config. We talked about that. Lab one. Yeah, we talked about that. We looked at the Rita list. We did that. Rita view. We just did that. Here's where we are now. That's the one I was looking for. So notice it doesn't show a bar, right? If I look at the Rita screen I have here, I've got a gray bar highlighting this item. And if I hit my arrow keys, I can navigate to different items. And as I do, you'll notice the right-hand side of the screen changes to reflect what data was associated with that connection pair. So I've got a little navigation bar to work with. Well, you may run into a situation where you don't have a navigation bar. Also notice the columns don't fit quite right. The coloring is off. We've run into this with some terminal programs that don't support 256 colors. Now, it may be a situation where your terminal does support that, but it's defaulting to like 16. And this is the command you can run to tell it, no, I want you to use 256, and that may fix it for you. But if you run this command and then you launch Rita and you're still seeing this, you're using a terminal application that doesn't support 256 colors. And the one that I've run into personally is Smart TTY, which really bums me out because it's one of my favorite SSH tools. But Smart TTY, for some reason, they decided 16 colors is enough. That's the most you can support. Well, we expected you'd be able to do, come on. It's not EGA world anymore, right? We're not stuck with EGA monitors. We figured everybody would have 256 colors. So, Windows command line handles this just fine. If you're not keeping up with command line, Windows command line, you got some problems. So if you can't get the colors to display correctly, where I'm going with this is if you can't get the colors to display correctly with the SSH terminal you're using, go back to whoever created it, saying, please give us 256 colors. It's not the 1900s anymore. We can do more than 16 colors. Please add in support, and that'll fix it for you. And with that said, let's take a break. So we're at the halfway point in the class. So this break is going to be for 20 minutes. So until 20 minutes after the top of the hour, we'll be on break. I will be on mute. When we come back, we're going to hunt this very first. I'm going to walk you through the Rita interface, and then we're going to hunt this very first one together. So I will catch you in 18 minutes. Talk to you then. All right, and we're back. So I noticed there's some problems with the OEF file, getting it running on VirtualBox. I apologize for that. Um, it worked when I first ran it. I'm wondering, did I go in and make some changes after that, and it didn't migrate through? I'm not really sure. But we do the best we can. So I apologize. It'll be better for next time. If anybody's not happy with the class, I will more than happily give you a 100% cash refund for it. So, but when we left, that was a joke, obviously. So when we left, we were looking at the new version of Rita, and I mentioned that you might have some issues with some terminal programs, and I mentioned, this is Smart GTY, and it still works. Everything's still here. The problem is you'll notice the first line looks a little lighter than the rest. You get that when you try to navigate through your items versus, the nice little gray bar that I'm showing you when I'm using the Windows command line to go through and do this. The color schemes aren't quite as good, but it's still functional. So this will, so even if you have like a bum terminal that doesn't want to support more than 16 colors, this will still work. It'll still work for you fine. It just won't look quite as pretty. One of the things I love, love, love about this is we've got severity levels now. So before you got like a beacon score and you got to see the duration along connections, but how do you prioritize between those two different types of persistence? It can be a little hard to kind of wrap your head around. Well, we've got a severity level now where everything gets organized in one spot. So it literally kind of turns into start at the top, work your way down. And, anything that's like medium or low, you're probably not going to be overly concerned about. If you're bored, it's worth going through the mediums just to be able to go through and hit them. But if this is hey, we're looking, we want a high probability of catching anything bad, high and critical are going to be the two that we go after for that. Over on the right-hand side, you get a summary. So some of this info was, again, buried in different screens in Rita. You had to go poking around for it. And now it's all in just one spot, which is kind of nice. So this is summarizing my source and destination again, just like it does here. Prevalence. What's this telling me? This is telling me how many of my internal systems are talking to this target out on the internet. Now, this says 1 of 1. Well, what that tells me is I only have one internal address that's being analyzed in this PCAP. So the fact that 100% of my internal systems are talking to this host doesn't really, because we're only looking at one system. Now, if we had 1,000 systems and this was the only one talking to it, okay, that's an interesting data point now. But we do this as a fraction to kind of give you an idea of, does this really matter? Is this really helpful? So, we initially did it just as a percentage. This to me is a lot more valuable. First seen. Now, when you're doing PCAPs, this isn't very helpful, right? Because if I've got like a 12-hour PCAP, it'll tell me, oh, it was first seen 12 hours ago, because that was when the PCAP started, right? It's the PCAP has a duration of only 12 hours. So when you're using PCAPs, first seen really isn't going to help you much. But when you get into things like using a rolling data set, and you've had Rita and Zeek up and running for a while, that's when it starts paying off, because we will keep track of all the first time you've seen every target on the internet up to 90 days. And after 90 days, it'll just say 90 plus. So we're still keeping track of it. We're just not going to give you the exact date, the exact number of days. We'll just say 90 plus, because after 90 plus, that says, hey, this has been on your environment for an extended period of time. But so with rolling, this becomes super helpful, because now I can tell the difference between stuff that I've been talking to for a long period of time, which tends to lean more towards it's probably safe, versus, hey, this just showed up today. This is something new and interesting. This is something I want to make sure I go in and I pay attention to. MIME type mismatch. What that's looking at is what's being pulled down as part of this HTTP session. If it is an HTTP session, and excuse me, what's being pulled down, and does that match the MIME type being advertised by the server? So in other words, let's say I'm pulling down a JPEG file, right? The URI points at image.jpg, but the server says handle it like a text file. Well, no, that should be an image slash JPEG because it's got a .jpeg extension to it. So that's a MIME type mismatch. That is a very common technique with command and control channels because they'll create a URI to a file that looks benign, like an image file, but they'll tell the receiving system, handle it like a text file because it's actually got command and control commands in it. And I want you to be able to go through and read those and process those. So we'll go in and we'll flag that if we see it. We'll go in and we'll flag rare signatures. Now, the way this is configured today is that if the system has a fully qualified domain name, let's look at the second line item here for a second. Tile-server, so this is going to end up being Microsoft.com. That's getting labeled as a rare signature as well. What we do is we look at what's the target that it's talking to and how many targets is it talking to? Is it only this one or is there multiple? And this particular data set, this user agent string, Microsoft.WNS/10, .0, is only being used for tileservices.weather.microsoft.com, but it's actually talking to about 12 different systems. So is it really unique? That's debatable, right? It depends on how you want to look at it because it's only using it when it's talking this one specific fully qualified domain name, but it's actually talking to multiple IP addresses that are load balancing that fully qualified domain name. So one of the things we're talking about doing now is maybe we change it to evaluate it based on IP instead. And the nice thing about that is, if it's talking to 20 different IP addresses as part of one fully qualified domain name through an Akamai CDN, that's big bucks. Malicious actors aren't going to give Akamai that much money to be able to do that. It isn't going to happen. So I think for small data sets like this, it would make that feel a little bit more accurate to be able to deal with. We've got our connection count, how many bytes were moved back and forth, and what were they communicating to. So they were talking to TCP port 80 on this system, and there was an HTTP header that was seen as part of that, which is kind of cool. So I like that we get a nice little summary here to be able to go through and kind of see what's going on. So this makes, so not only do I only have one spot to look in now to be able to get all the data I need, but it also means that, excuse me, it also means that I get more data than I used to, which is really cool as well. Now, a couple other things. See these double little dots down the bottom right here? This is a page count. So this tells me how many pages of data there are. So I'm going to hit my right arrow key. And when I do, you'll notice this dot lights up and this one, the right-hand dot will turn gray or will get brighter. And then the left-hand one will get darker because I've scaled to the second page. So this is the second page worth of items. And notice I've got some low ones and I've got none. This is definitely not something you need to be concerned about. So I'm going to left arrow again, and that'll put me back to that page. So I could hit the down arrow, scroll to the bottom of one page, and when I hit down arrow from here, it'll automatically jump to the second. That's one way I can jump through the different pages. Or I can use the left and right arrow and navigate around that way instead. Now, a bug that I need to address, which is these two long connections. Notice anything interesting about the long connection time? They're identical, right? What's going on there? Let's see if we can't figure it out. So we're going to use one of our utilities for this. So I'm going to grab this IP address. I'm going to highlight that and hit enter. And then I'm going to quit out of Rita and I'm going to say FQ space that IP address. And notice what that IP address points at, bn3p.wins.windows.com. Let me go back into my interface again. That's the system. So what's happening here is we end up tracking and reporting the IP, this long connection as an IP and also a fully qualified domain name. We incorrectly double the entry, if you will. That this has turned out to be a bug in the code. I've already talked to the developers about it. They know what went wrong. There's a fix in for it that will be part of the next version of Rita. So this will go away. But the side effect is with this specific version of Rita, the one that's facing public right now, you may end up in a situation where you're technically hunting the same thing twice because it shows up once as the target IP and shows up once as a fully qualified domain name, but it only happens with long connections. We haven't seen this happen yet with beacons. It's only a long connection thing. So just kind of a minor bug to be aware of as we go through. So the bug so far is long connections may get duped, once for the IP, once for the fully qualified domain name. And the other, I don't know if I'd call it a bug, but what's the proper way to look at it is what makes a rare rare? Is it the fact that it only talks to one fully qualified domain name or one specific IP address? If I go back again to my command line, and I say FQ space tile dash service, the first part of that fully qualified domain name, look at all the different IP addresses that are associated with it. So if I'm looking to see if the user agent string is unique to this, right? Well, it is, because the only time we use that user agent string is to talk to this fully qualified domain name. But it's not unique if I look at an IP address level. And I'm feeling like we might get better data results if we look at it based on IP. If you feel different, please throw it into Discord. I'd love to see what other folks kind of think about this. But those are the two bugs that I've kind of run across so far that really need to get addressed. Okay, so let's do a hunt on this first one together. So one thing I'm going to do is I'm going to get another terminal session going. How to close the Reader console. So when you're in this screen and you want to exit out, just simply hit the letter Q. And when I hit the letter Q, that'll get me back to my command prompt again. But I want to grab my IP address again because I don't remember it. Oh no, I want to do a -W so I don't get the IPv6 addresses in there. And I'm going to set up a new SSH connection to that. Just so I don't have to keep exiting Rita every time I want to run something on the command line. And set a keep alive just to make sure this connection doesn't die. And there we go. Cool. So now I've got a second SSH session running here. So this is Smart TTY. And why didn't you just run another command line prompt, Chris? I could, but then I got to switch back and forth between the command prompts. What I like about one of the many features of Smart TTY, even though it's only 16 colors, is if I need to open up a new terminal session, I just hit the plus. And now I've got two terminal sessions running at the same time, just within this one interface. It makes it a little bit easier to work with. But let's go back to Reader again for just a second. I'm going to pull up my Reader command. And let's go through and do a hunt on this first one together. So the severity is critical. What does that mean? That means that we saw enough things about this to say this looks super suspicious. This is something you really want to pay attention to. And some of the things we saw is we were 100% certain this is a beacon. So that's something we may want to explore a little bit. We'll look at that in just a second. There was a rare user agent string being used. MIME type mismatch is being highlighted. So there was some form of MIME mismatch that took place as part of that session. So it was the combination of these items that caused us to say, hey, this is critical. This is something you really want to go in and pay attention to. Now, one of the things that's kind of grabbing me off the bat is this is an HTTP connection to an IP address. This should be showing a fully qualified domain name, right? Like if I go to the second line, see, this is an HTTP session. This is the host parameter within the HTTP header, and it's a fully qualified domain name. This one doesn't seem to have that. So what I'm going to do is I'm going to run my FQ command against that IP address. So this is going to check the DNS log file, the http.log file, and the TLS, or excuse me, the SSL log file for instances of this IP to see what I can learn about it based on the Zeek data. So the first thing that kind of, oh, and I'm in the wrong directory. That would help. So the first thing that kind of grabs my attention is this. It's no DNS information. That means we connected to this system based on a direct IP address. Oh no, that's not good. Right? We're using, we expect someone was using a web browser to go to a site. We use fully qualified domain names there. We don't use IP addresses. We can, it'll work, but it's rare. It doesn't automatically mean it's evil, but it does make us go, that's kind of strange. That's kind of bending the rules. This here is showing me that this was the host parameter instead of that HTTP header. Well, that host parameter should be the fully qualified domain name of the website we were trying to get to, and it's not. So that definitely raises red flags for me, because the only time I've seen that is when somebody's up to no good. Somebody's doing some evil. All right, let's take a look at the con.log file on this, right? Because it's calling it out as a beacon. Okay, let's go in and kind of take a look at that. Actually, there's two ways we can go in and we can kind of analyze it, and we'll look at both of them. So I'm going to say less space dash capital S space lowercase x, and then I'm going to say 50, I think was the value I was using before, and then con.log. So I want to use the less command to view all the entries that are inside of con.log. And we'll kind of take a look at what's in there. So here's my source IP address. That destination IP address does seem to show up a lot, right? So it does look like there's many connections to it. How many did this say there was? This says there was 2,868 connections. Yeah, we can see those taking place, right? And I'm going to just highlight a couple of lines here. So I'm going to highlight these two lines that are associated with that target IP, so that as I scroll right, I know what lines are associated with that, with the communications with this target IP. So TCP session 80, it does have a valid HTTP header. They're pretty short in nature. There's just a small number of bytes being moved back and forth. See this nomenclature here? That's a summary of the TCP flags that were being used. So SF means I saw a normal TCP session. There was a 3-packet handshake. It closed with a FINAC exchange at the end. Everything went normal. When you see something like this tells me like the client sent a reset packet or the server sent a reset packet. Something caused that connection to end abnormally. So I can see all sorts of general communication information about that system. But what's really going to be interesting is when I go in and I look at the http.log file. Like that. Because this is what's going to have the interesting stuff in it. So these first couple of lines are all that same target IP. So I'm going to highlight those just so we can figure out what's what as we go through our additional data. So this was going to TCP port 80. There were GET requests. Now, notice the IP address shows up here. This is the host parameter. That should be a fully qualified domain name, just like we see here, and it's not. So again, that makes it super suspicious. So they were doing a include template isx.php. So it looks like they were trying to get a PHP file, which means they were trying to execute a PHP file on that server. Now, this is interesting. See the refer field up here, spelled incorrectly? Spelled correctly, it's spelled incorrectly in the HTTP header. The refer field is where was the user? Why does mine look different? So your output might look different if you didn't use the same switches I did. So let me copy and paste that into chat so that everybody has it. So that -X50 is what's setting up all the column widths for me. That's what's making it so that everything doesn't run into each other, which you might be running into. All right, let me highlight these again. So we're doing GET requests. for that index HTML file. So the referrer field is saying the user was at Google and Google was what told them to go to our website. No, no. Couple things. So the story this is telling is that the client, our system, went to Google and did a search, and that search caused them to go to this specific website and access this PHP file. Right? That's what the referrer field means. The referrer field is who sent you to this location. There's a number of problems with this. Problem number one, we don't see any traffic before that going to Google. We should see that because it's the client connecting to it. We don't see that in there. So that's problem number one. Problem number two, Google doesn't support HTTP anymore. It's all HTTPS. It's all encrypted. So that's problem number two. Problem number three, you never see just www.google.com. What you would see is what were the search parameters that were used in Google that caused this page to be referenced? And we don't see any of those search parameters. The other is that once you went to Google once and then went to the website, the referrer field isn't going to show up anymore because you've already been referred to that site. You don't refer between different pages on the same website. It's from one unique site to another. So this being here is bad on so many levels. This tells me this is definitely packet crafting. This is not somebody just using a web browser. Somebody's screwing around here. All right, it's HTTP 1.1. Here's the user agent string. This looks kind of odd. NT 5.2. Well, we can see here where we're using Microsoft Crypto API version 10. So this is a Windows 10 system. But that's like, I don't know, Windows Server, something like that. It's pretty old. That this doesn't, Java 1.5. Oh, that's ancient. So is it an ancient system or is it a Windows 10 system? Yeah, that just doesn't sit well for me either. Let's see what else we got in here. So the server status code came back as okay. So when they tried to get to that PHP file, they said, "Yep, we got that. Here you go." So all of that checked out. Let's see what else is interesting in here. Get some hashes. Don't care about that. Ooh, we care about this. Response MIME type. So here's that MIME type mismatch. So the response MIME type, well, they were accessing a PHP file. So we expect the MIME type to be returned by the server to be application PHP, right? This is an executable. So here, application PHP, you're trying to run this PHP file. And it's saying, no, process it like a text or an HTML file. That's why that alert of a MIME type mismatch came up. That's wrong. That shouldn't be like that. So this first one is looking super evil to me. This definitely is looking like something that, yeah, we got to pay attention to. Now, the one last thing I want to look at is there's 100% beacon score here. Why was it 100%? Well, I'm going to highlight those two IP addresses, hit enter to highlight it because I'm on the Windows command line. I'm going to come back into my other terminal here and I'm going to type FQ. Oh, excuse me. Nope. I'm going to type in beacon based on the con log and then those two IP addresses. And what this tells me is that I'm seeing, okay, it jumped up and down a little bit initially. But look at this, 119, 120, 119, 120, 119, 120, back and forth, back and forth, back and forth. This is going off 120 times each hour, which means this is going off about once every 30 seconds. Now, is it exactly every 30 seconds? And it just happens to miss the hour change sometimes, and that's why it's jumping back and forth between 119 and 120? Or is there a little bit of jitter here, right? Maybe sometimes it goes off at 28 seconds, sometimes it goes off at 32. We can't tell at this level of resolution. This won't show us that. This is just this script just simply gives us an overview of the 24-hour and 1-hour buckets. But I look at that and I say, oh, yeah, that's a beacon. That is definitely a beacon. So we've got a beacon that is claiming to be a Windows XP system. Thank you for looking that up. That has a MIME type mismatch, oh, this is evil. I'm worried about this. Definitely hit the big red incident response button. Here, I got a big red incident response button. I'm going to hit it now. That's my big red incident response button. So we definitely want to go into incident response mode on this one. Now, what is it? This is where it gets a little dicey. How do we run this down? We could go to that system, try and figure out what binary is causing this to take place. If we're logging that information, that would be super helpful. Is there clues in the data? Yeah, there might be. If I go back and I look at that http.log file again, there's some things here that really stand out for me. Like this URI, if I Google that, might show me something kind of interesting. That user agent string that was unique, that might show me something. That might come up with something for me. So I would go in and look for what makes this odd versus normal traffic. Google help me out. And I do some research that way. And if you do, I think this one ended up is Fiesta, if I remember correctly. And this is the string of characters that will clue that in for you. I believe it was Fiesta with a like a Clockser delivery system or something along those lines. But Googling this is what will lead you to the research that shows you, oh yeah, no, this is bad. This is something you really got to go in and pay attention to. Cool. So to summarize, I just started at the top of the list, took the very first item, said, okay, it's got a severity of critical. Why does it have a severity of critical? MIME type mismatch. Let me check that. What does that look like? Oh, hey, the user agent string looks weird. Let me check that. Hey, there should be a fully qualified domain name because it's HTTP and it's not. So I just kind of took the data that Rita was giving me and maybe went a little bit deeper down the rabbit hole on each. Like it said, hey, 100% beacon. Well, I ran it through beacon.con to be able to get a look at, okay, what's the signaling look like? Yeah, I can see why it said that's 100% a beacon. And that's what allowed me to go through and kind of run this down and figure it out. Okay, with that said, lab time. So here's what I want you to do. So we just ran down this critical one together. I want you to take the next three. So there's three high priority items. Wait, Chris, there's four showing there. Yes, but remember I said this line, this IP address, and this fully qualified domain name are actually the same thing. And we can see that based on the duration time that shows up here. So I'm counting this as one. So I want you to look at 1, 2, 3 high priority items, and I want you to tell me safe list it, incident response mode on it, one or the other. So let's do this as a lab. I'm going to go on mute while you do the lab. If you have any questions, just please feel free to go ahead and throw that into the Discord channel. So I'm going to give you a little bit of time to work through this one. One other note for you. If you think you have the answers, right? You know, if these three high severity items, if they're good or evil, and you want to post it into Discord, please use spoilers. What are spoilers? Spoilers are the two pipeline commands before and after what it is you want to type in. So if you want to give that a try right now, go for it. So just type in pipe, some message that you want to have show up hidden, and then pipe again, and you'll see what a spoiler looks like. So a spoiler just listed as a blacked out box that people can't read. And the reason I'm asking you to do this is if you're going to give stuff that is going to give away the answers, don't spoil the lab for everybody else, please. You know, use the spoiler tags. That way, the folks that are done doing the labs and it won't be spoiled for, they can just go click on that black box and see what it is that you posted. All right, going to give you some more time to go through this. All right. So I'm not going to cover the answers yet. I want to give you a little bit more time. But somebody asked about the search function. So I want to be able to kind of talk about that a little bit. Because you may have noticed there's a search box up here. Cool. So what can I do with that search box? Well, hey, I can search for things. How awesome is that? How do I search for things? Well, I can press the / key, and that'll go through and that'll pull up the search functions. I can also, if I hit question mark, that'll give me help. So this tells you what are valid things that you can search or sort for, what operators can be used, a little bit of a description about what's going on. So all of that will allow me to run through and kind of do all of that. So for example, let's say, excuse me. So by default, things are sorted by severity, right? What if I wanted to sort them based on beacon score? Well, in that case, I would hit backslash and I would say sort colon beacon. And then I have to tell it, do I want to do it ascending or descending? So let's say I want to do it descending, DESC, and then I hit enter. Now notice high, low, medium isn't what's sorting it. What's sorting it is the score on the beacon itself. So if I wanted to like just focus on beacons for some reason, I could go through and do that. If I hit backslash again, that'll pull that back up. You can do some pretty complex stuff with this as well. So let's say I want to kind of filter some stuff out. So I only want to see beacons where the score is, let me think about this. It's greater than or equal to. Yeah, so it's greater than or equal to 80. And now if I run that, all my long connections go away. I can only see my beacon scores of 80 and higher. Okay, I've got some different durations listed here, right? Let's say I wanted to say, okay, I don't want to see, excuse me, all beacons with a score of 80. I want to, let me hit backslash and that'll get me at the end of the line. And I'm going to say, along with beacons, the beacon score having to be greater than 80, I want the duration to be, I don't know, greater than equal to, we'll call it 40 minutes. Yeah, 40 sounds good. So I'll say 40 and an M for minutes. Hit enter on that. Oh, hey, look, that brings us down to 2. So I could do that. And if I had a lot of entries, I could pick something else I want to sort on as well. So the search allows me to go through and resort the data if I want to do that, or focus in on specific things if I want to do that. Backslash is what gets me up to that menu all the time. And notice it'll pop up in red if my command isn't quite right. And if you ever forget what are valid options, just hit the question mark. And that'll pop the screen up for you, and that shows you everything here. So that's how to go through and do searches and things along that nature. And then to get out of this, I'm just going to hit the escape key a couple of times. That'll get me back to here. And actually, I got to tell it backslash enter with a blank search, and that'll clear that last search. So it's back to the display that it was on before. Cool. All right, let's take a break. It's top of the hour. We'll take a break until 10 minutes after. I'll give you a couple more minutes to go through these, and then we'll go through and we'll cover them together. See you in about 9 minutes. All right, we are back. I see some people posting some answers in the Discord. That's awesome. I'm going to give you another minute or two, and then we'll go through and we'll cover them together. So if you're having trouble getting through them, don't stress about it. I'm going to walk you through it in just a minute or two. So I'll give you a little bit to finish up. Okay, let's kind of talk through this one a little bit. So we wanted to go through the high severity items. We had 3 of them because we said these were the same. And they're the same because of a bug in the code. It should have only listed once, and that's it. I'm not considering this a severe bug because you won't miss anything. You'll just unfortunately duplicate some work, having to run 2 down instead of just the 1. But we are getting that fixed. It will be fixed in the new version, like I said. But there's 3 high severity items. And the first one is tile services. So this is going to weather. We think that's going to say Microsoft, but we'll want to check it out just to make sure. And it's TCP/80 traffic, 48 connections. So that's about twice an hour, or it probably is twice an hour. That's why the beacon score is so high. But there's very little data that was moved, 260 kilobytes. That's it. So that's not much. So where do we even want to start with this one? Well, I usually start with that FQ command. So I hit Q to quit out of that skein. I'm going to type in FQ. Now I could type in the entire fully qualified domain name, and I would if I was worried about, like I would never just type in www because you're going to get a lot of matches on that. But tile-service, that's enough to make it unique versus any other entries I might have. Now, when I do that, notice there's been multiple lookups for tile service. that have resolved to multiple. So look at this name here. That is the nomenclature that Akamai uses for their customers. So weather.microsoft.com. So this is going to getting redirected to a Microsoft server on the other side. The fact that there's so many of them tells me, yeah, because Akamai charges you by, yeah, how many CDNs do you want to put out for your customers to be able to access? Your subscription rate is going to go up, based on the number you want to use. Nobody pays for this many unless they're a huge organization like Microsoft. So we don't have a digital certificate to work with here. We could go in and start poking at, what data was being sent back and forth. We wanted to look at that too. But just the fact that, yeah, it's going through Akamai to get to Microsoft. The domains match up. This is kind of enough to me to kind of look at this and say, yeah, I think this one's okay. I don't think I would be that concerned about this one. This is tile service is probably one that I'd want to safe list. Further, I know from doing research that this is a known connection that Windows systems make. If you have the useless tile desktop, like it's a pad instead of a computer, and you have the little widget up to check your local weather, this is what it does. It checks in with this service twice an hour to see what's weather in your area so it can present you an accurate weather forecast. So for all of those reasons, yeah, I'd look at this one and say this one's okay to get safe listed. All right, let's go on to the next one. So the next one is this IP address here, which also is associated with the fully qualified domain name below it. But again, I'm going to start off and I'm going to do an FQ query against that IP just to see what comes back. So my FQ query is looking at what DNS info do we have, what HTTP info do we have, what TLS info do we have. So this comes back with, and actually I'm going to copy some things over to my notepad, and that's in getting ready for the next lab, and I'll throw these into Discord too. But we had tile services, and now we have this one. So I'm just going to copy those off for now. And I'll come back to it. But notice the TLS entry, right? Notice that second line entry we have in here. It's saying this IP address, when we connected to that IP address, this was the SNI information that was being conveyed. So this was the host name at the application layer. I always check to see, does it match DNS? These should be the same. And notice in this case, they are. So that's good. It passed that check. This is another big one for me. This okay means that Zeek used Linux's subsystem, or it used Linux's digital certificate store to go out and validate, is this a valid digital certificate, yes or no? And Zeek was able to validate it. So we've got a connection going to the fully qualified domain name matches the SNI and it's a valid digital certificate. Now you could argue, well, hey, what if somebody got into the certificate authority and issued a bogus digital certificate? And yeah, that's possible. So, we're never 100% with this stuff. But based on this information, I'm 98% certain that, yeah, this is okay. Right? So this IP address, this fully qualified domain name is okay. So my second line item, that goes with this fully qualified domain name here. Those are both okay. I don't need to worry about those. Great. So now I'm going to go on to config.teams.microsoft.com. So again, if I do a little research, this is a known host. This is associated with, using Teams, obviously. It's a SSL session. 24 connections, so it's going off once per hour. Again, not a whole lot of data being moved. So I'm going to go in and I'm going to copy that fully qualified domain name. And then I'm going to go in and I'm going to say FQ paste that name. We'll see what comes back. And this is telling me, well, somebody looked up config.teams.microsoft.com. And when they did, they got back the CNAME information. And then they got back this IP address. There were no HTTP sessions associated with that fully qualified domain name. There were TLS connections. And in those TLS connections, notice my FQDN that was queried matches my SNI information here. And again, the digital certificate turns out to be okay. So this looks like it's fine. This looks like this is one that I don't need to worry about. So when we look at these three items that are being ranked as high, they're all okay. So what do we do? Well, we could just say, well, they're fine. I won't worry about them. And they'll pop up in the next hunt and the next hunt after that, and the next hunt after that. And we'll have to deal with them over and over again. And we may not necessarily want to do that. So how can we go through and fix this so that we don't need to go through and do this over and over again? Well, one way would be to go in and create a safe list entry for this. So I'm going to quit out of this, and I'm going to go back and I'm going to edit the configuration file for Rita. So I'm going to say nano space /etc/Rita config HJSON, and I will throw this into Discord so everybody has this. So if you want to go in, so what I'm going to do is I'm going to add some safe list entries. So if you want to add some safe list entries to your system as well, go through and do it. Now notice when I did that, file /etc/Rita is unwritable. What does that mean? Well, I'm going to hit Control X to exit back out. I just ran nano, but I'm trying to edit something that's under the etc directory. That's going to be owned by root. So what I should have typed in is sudo. I gave you the wrong command to start with. So let me throw that into Discord. So now when I run this command, notice I don't get that error message. Great. So we're off to a good start. Now, I want to add in some safe list entries. How do I go about doing that? Well, my safe list entries need to get added to the exclude section. We looked at that one a little bit earlier. So what I'm going to do is I'm just going to scroll down, and we get into this section here, the never includes. And we're going to add them in here. Now we got two options. We can add them in based on CIDR, based on an IP address, or we can go in and we can add them in based upon fully qualified domain name. We can do it either way. Fully qualified domain name is always better anytime you can do that, because it's just, it's better because if the system gets, moved to another host, usually the host name tracks, but the IP address doesn't. So this is going to make things a little bit easier as we. I am going to add in one IP address entry here, just so you can see the syntax on how IP addresses get entered. Just to make sure you know how to actually go through and kind of add things in. So I'm on this first line here, never include subnets. And notice I've got my little highlight bracket right by the right-hand brackety thing here. That's where I'm going to go in and start typing. So as I start typing, that bracket will get moved off to the right. And I'm just going to go in and I'm going to add in one of those IP addresses. Now, anything we add in here has to be enclosed within quotes. So I'm going to type my quote character, and then the IP address, which is 52.113.194.132. And that's my IP address. Now, I have to, notice it says array of CIDRs. I need to include the CIDR format. CIDR format is how many subnet mask bits are there. So if I wanted to, let's say, do the entire class C, I would say /24. But I only want to do this one IP address, so I'm going to say /32. That tells it this IP address only. Add a quote, and now that line entry is done. So I've got an IP address that I've added in. Now I'm going to go down to the second line, and we're going to actually add in multiple entries in here. And I'm actually going to go through and lay these out, and then I will type it into Discord for you, just because there's more to type and it's easier to go in and make an oopsie. And I don't want folks to make oopsies. So here's what I'm going to be adding in. Where'd my Discord screen go? Come on, Discord. I know you're there. There you are. Yeah, so it isn't just X, it's Control X to be able to exit out from Nano. Okay. So that is what I'm going to add in under never include domains. So I'm highlighting the right-hand bracket, and then I'm just going to right-click to paste it in. So here's my syntax. So I've got the left-hand bracket, quotes, my first fully qualified domain name, close quotes, comma, second fully qualified domain name and closed in quotes, comma, third fully qualified domain name, closed in quotes. So what I'm telling Rita is anytime you see this IP address or these fully qualified domain names as the target, don't score them. I don't want to pay attention to that. And that's all I should need to do. Now, once I've done that, I'm going to hold down the control key and hit the letter O. And when I do, this pops up and it says, what do you want to write this file out as? And the default is to overwrite the existing file, which is exactly what we want to do. So I'm just going to hit enter. And when I do, it tells me wrote 125 lines. Great, it saved it. So now I'm going to hit Control X, and that's going to exit out. So I've just modified Rita and told Rita don't pay attention to those systems. So now anytime I import data from now on, it's going to ignore it. So I'm going to go back and run Rita import -L, and I'll give you this command. I'll paste this one in. Lab1 directory. That's where my Zeek logs are located. -L lab1b. Copy that, paste it for you. And now I'm going to run it. Logs do not exist. What do you mean logs do not exist?
Chris, you got 2 -Ls.
Oh, thanks, dude.
No problem.
That would only take me 10 minutes to figure out.
20 for me.
Yeah. Okay. So that second -L that I pasted in should have been a -D, specifying the database name. All right. And now it's working better. Yay. So once this is done, now I'm going to say Rita view lab1b, that new data set we just created. And when I hit enter on that, look at that. We're down to one critical item. And that's only showing up because of the bug I talked about. Once that bug gets fixed, we'd have no more high items anymore. Everything would be medium and low, except for the one critical that we already decided, yeah, this is evil and this is something we have to worry about. So I can go in and I can create some exclude items to go through and create some safe list entries that way, which is kind of cool. Awesome. And mediums and lows, we're going to ignore those. Now, safe listing for the remainder of the labs, I'm going to skip it for the most part, just because it's a little time consuming to go through and do it. We may do one more just to kind of give you another chance to kind of hit it again, just so that it's something you feel comfortable with. But I'm not going to do them after every single lab. But if you were doing threat hunting in the real world, yeah, after each hunt, you're going to want to be able to safe list the new things that you found that you decided were safe. So that's the process for this. Let's see. Yeah. So with that said, I think we're done with lab 1. So let's go to lab 2. So I'm going to say cd space .. lab 2. And that's going to let me navigate over to the lab 2 directory. If I look at what's there, I got a PCAP file. Yay. Trust me when I say it's a 24-hour PCAP file. It'll save us from running one command because we're running a little bit behind on time. I was a little bit too exuberant in adding in labs. So I want to make sure we get through everything by the end of class. So the first thing we're going to do is create Zeek logs from this PCAP file. So I'm going to say Zeek read, READ, PCAP, and then I'm going to then I have to tell it. So that's add a tilde, lab 2, and then the name of the PCAP is lab2.pcap. And now I have to tell it, where do you want to write those Zeek logs? I want to write them to a tilde lab2, put them in the same directory as the PCAP file. So this one takes a little longer to run because the PCAP's a little bit larger and there's more data in it. But this will go through and process relatively quickly. And then once this is done, the next step we need to do is we need to go in and import those Zeek logs into Rita so that Rita can go through and check that data to see, is there anything in here that's persistent that's maybe worth going in and paying attention to. So that'll be the next step that we do. And this should be just about done. Come on, you can do it. There we go. Yay. And oh, by the way, all these commands are on the lab 2, which is at here. So slide 139, here's all the commands that I'm running right now. So we write in the PCAP file. Now we need to import this into Zeek. So I'm going to say Rita import. So I need to tell it -L, where are those log files located? Well, they're located in the lab 2 directory. And -D, not -L again, -D, what do I want to name the database? I want to name it lab2. Let Rita go do its thing. And then once this is done, I'm going to go through and do a Rita space view space lab2 to be able to review the data. And if I wanted to, I could say Rita list to show what databases I have. And this will show me, oh, hey, there's the lab 1 I created. Then I created 1B, and now I just created 2. And now I can do Rita view lab 2. Awesome. So we don't have any critical items here. So that's good. But we do have 3 high items. So I want you to review those. The one thing that I want to kind of point out, because we didn't have any data for me to show it to you when I first showed you the Rita interface, is this column here. What does this mean? This means that there were 165,378 unique resource records looked up that were part of cisco-update.com. Well, that's cool. Yeah, it's Cisco. So I'm sure that's going to turn out to be fine. But I want you to look at all of these 3 items and say, okay to safe list, which we won't do, but we'll just make a note if they could be safe listed or not, or incident response mode, we think we have a problem. I'll give you a chance to run through these. I'll be on mute while you do. Any questions, throw it into Discord. Let's talk through some of these. If you didn't finish up by now, don't sweat it. I want to make sure that we've had an opportunity to kind of go through stuff together. There's absolutely nothing wrong with all of this is going to get posted to YouTube. So there's nothing wrong with maybe making notes of like, hey, I started to get confused at slide 124. And now you can go back to the YouTube video, zip through to slide 124 and, listen to it again and go back through it again. There's also nothing wrong with going through and hitting the labs a second time. But I want to make sure that I get everything done before we hit the end of the hour, or excuse me, before we hit the end of the class. So we've got, let's take a look at our first item here. So we've got an internal IP address talking to this external IP address, and it's NTP 120, or excuse me, UDP 123, and the application layer says it's NTP. So this looks like it could be a time check that's taking place. Cool. If it was a time check, that wouldn't be that bad. Okay, how are we going to kind of verify this? Well, let me get my second terminal in here. Well, let's go into the configure out on this one. So this one is in the lab 2 directory, so I need to move over to there. And here's where all my files are located. So what's the first thing I want to check? Well, the first thing I want to do is, no, I didn't want that. I wanted this, and I wanted to copy that IP address and grab that IP. I like to copy it just to make sure I don't like fat finger and get a number wrong, and then I'm not sure what's actually going on. So if I say grep, grep, space the IP address, grep is a command line tool that will search files for a string you define. So I'm telling grep, go find this IP address for me. And where do you want to look? Well, Rita said it's NTP traffic. So I'm going to go take a look at ntp.log and see what's there. ntp.log. Now, if I just hit enter, everything scrolls up past the top of the screen. What do I do? Well, I get a couple of options. I could use that less command that we talked about before, or we looked at before. I could go in and I could say less space dash capital S X 50 or 40 or whatever, some large number. And then I could scroll through these if I want to. One of the other commands I like to use, which I haven't shown you yet, is head. So by default, head says, show me 10 lines of output. So now rather than scrolling up off the top of the screen, all my entries are here. But I don't think I need 10 entries to look at. I can go in and I can give it a number. So I can say head -5. Only show me the first 5 lines of output. So what am I looking at here? Well, these are actually queries for time. So this does look like it's actual just real NTP communications that are taking place. So it looks like, yeah, this may just be a system checking its time. The one last check I think I want to do is I'm going to use dig. I'm going to say -x. I want to do a PTR record lookup. So the -x says, that's not what I wanted there. The -x says, delete it all. Rather than doing a regular A record lookup, I want to do a PTR record lookup. PTR record lookup means I've got an IP address. I want to see the host name that's associated with that. So that's what that's going to do. Now, if I run this, dig gives me all sorts of information. Right? Like, here's the number of queries that were sent out. Here's the number of answers that came back, authority, additional, blah, 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 blah. I don't care about that. All I care about is what got returned from that query. Well, I can use grep again to go through and search for that. So I'm saying grep space ARPA. So what that's going to do for me is that's going to give me, that's going to show me just the stuff I actually care about. So when I run that command, notice what comes back. Here's the PTR record right here. So it says, oh, that IP address, there's no name associated with it. It doesn't have a fully qualified domain name. Okay. It could be true, but that's kind of weird. And then, but it also, and this is why I do the search for ARPA, is that it also gives me the start of authority. The start of authority tells me who's responsible for this address space. So if the system doesn't have a fully qualified domain name associated with it, the SOA will at least tell me what's the organization that's managing that IP address. If it's evil.ru, I'm going to be concerned. If it's, in this case here, canonical.com, okay. If this turns out to be an Ubuntu-based system, the fact that an Ubuntu-based system is calling out to Canonical to check on time, that seems legitimate. That certainly seems entirely plausible. So now I need to kind of figure out, is this an Ubuntu system that's sending out these requests? Well, if I go back and look, my third entry from that system is connectivity check .ubuntu. So let's check out connectivity check and see what we can find out. So if I look at what's this connecting to, it's connecting to, or how is it connecting? It's connecting via TCP/80 HTTP traffic. Great. So I know I get some TCP/80 to go in and deal with here. Now, let me get my other terminal back here. So a couple things I can go in and look for. I can say FQ connectivity check, and that tells me, okay, connectivity check is actually associated with a bunch of different IP addresses. There was actually 3 different IP addresses that it was being connected to that caused that, that activity to kind of go in and get rated. So, okay. So we've got what we expected. There was a DNS query that took place, and then it comes back with that. So that's fine. What else can I figure out about it? Well, let's do a dig request on this one too. So I'm going to say dig-x, paste in, connect. No, I want the IP address. Let me just grab one of these IPs. And I'm going to say grep ARPA. Same command I ran last time. So now I've got kind of the same thing here where it's saying, well, so there's no PTR record associated here, but there is a PTR record here. GoogleUserContent.com. That's kind of interesting. So connectivity check.ubuntu seems to be getting mapped back to Google for some reason. Why is that? Well, do a little research, and what you'll find is that Canonical is actually using Google Cloud. So this is probably going back to a system that they control. So I've got this system is connecting back to Canonical to check time, and it's checking back to Canonical for connectivity check. So this sounds like it's just like a basic connectivity check that it's doing, right? Let's go take a look at the http.log files. So I'm going to say, let's see, how do we want to go through and do this one? I'm just going to less it. Less space HTTP. Actually, let's do capital S X50 to give me some column title. Actually, I probably don't need that much. I'll just put in 40. 40 is probably plenty for the column width. And I want to read that out of http.log file. And then once we get in, I'll do a search for that IP address. So I just hit the / key, and it's going to do a search for that, actually the fully qualified domain name. And here you go. We got a full page of them. Great. So let's take a look at what we got here. So we've got our source IP coming from an upper port, talking to a couple of different IP addresses, doing GET requests. Here's the host parameter. So it's the same in all of these. That's fine. It's doing a query for the root of the web server. So it's not actually looking for a specific file. It's just connecting to the server. When it does that, the server is configured to say, hey, if somebody just connects to me, I'm going to have a default page I'm going to serve up to people. And it's usually index.html. This is the default file that it uses. So it's going to try and serve up the index.html file. And the response code from the server was no content. So we connected to it, but no content came back. Well, that's kind of weird. Well, I guess if it's a connectivity check, maybe it's just looking to see if the server is there. And if the server responds, it considers the connectivity check to be valid. It's like pinging something. That entirely could be possible. But then why do you not use ping? I'm a little, no content is certainly possible, but I'm not too sure about that. So here's what we're going to do. We've got a PCAP. So we've got full payload decodes of this. So I'm going to go in and I'm going to take this a step deeper. And I'm going to say, hey, I'm going to use TCP dump, which will allow me to process that PCAP file. I'm going to say -NN, don't resolve IPs, don't resolve ports. -X, I want you to decode the payloads and anything that's here. I'm going to say -R, I need to give it the PCAP file that I want to read. And then I need to go through and tell it any filters I might want to use. Well, I'm just going to say host, and I'm just going to grab that first IP address. And then I'm going to pump that through the less command. All right, let me copy that. I'll throw this into Discord for you in case you want to run this command as well. And here we go. So here's our TCP 3-packet handshake taking place here. Here's our GET request right here. And notice the GET request is just for the root of the drive. It's an HTTP 1.1 connection. The host parameter is that fully qualified domain name that we looked at before. And then notice it immediately closed the connection after that. That's kind of how HTTPS works. Hey, here's some data I want. I'm done. And half the connection's now done while the other half sends the data. Okay, here's our response. It's this packet here. So HTTP 1.1, it's returning a code of 204, which is there's no content here to serve up to you. But now here's where things get a little interesting. It's saying I'm not serving up, but here's a date timestamp. So I'm going to tell you what time I think it is. Here is the server I'm running, Apache on Ubuntu. This is the one that kind of gets me. X Network Manager status online. What does this section mean? So when you look at, if you do some research and you look at what tool on Ubuntu actually tries to connect to connectivity check, it's actually Network Manager that runs within the X Windows environment. So it's actually an X Windows tool called Network Manager that goes and checks to see the status. And all it does is it gives you a little green light that says online, meaning you're connected to the internet, or a little red light that says offline, meaning you're not connected to the internet anymore. And that's all that tool does for a living. That's its full reason to exist. But it's feeding back that status code as part of the HTTP header. So this to me is kind of, they're bending the rules, right? Because it's saying we're not giving you back any content, but yeah, they are. They're signaling to this tool to change its status to online or to set its status to online. So we are actually feeding data back to the client, even though it claims it's not, it is. And I think vendors do this because when they put stuff in the payload, we pay attention to it. But we tend to ignore stuff in the header sometimes. And by putting it in the header, maybe people won't notice this. Let's see. The filter should always be the last thing on the command line. On Linux, you may want to put the filter in single quotes. Yep, you could do that. So what I found is that if you're doing something simple, like host space and IP address, you don't really need quotes around it. But if you're going to use any special characters, you do. So for example, let's say part of my filter was I only want to look at SYN packets. Well, to create a filter in TCP dump to look at SYN packets, I'd have to say TCP bracket 13 bracket equals 2 or ampersand equals 2 if I want to make sure I match syntax as well. Well, ampersand is a special character, right? Usually Linux, when it hits an ampersand, is going to say, oh, that's the end of the line and I need to run this as a background process. In that case there, I have to put quotes around it or it's going to choke. On Windows, use double quotes. Yeah, so if you're using Windom on Windows, you use double quotes instead of single quotes. So I went down a rabbit hole on that, right? I said, they say they're not giving us any content, but they are. They're signaling to a tool running on that system that it should put its status in an online state. Do I need to worry about this? Well, what are we worried about? We're worried about compromised systems calling home and creating command and control channels. Is that what this is doing? No. Do I need to worry about it? Probably not. Okay. So that's two of them. So the last one is this Cisco update. Okay, let's take a look at that. So this says no direct connections. Well, remember I said that when C2 over DNS is taking place, one of the behavioral characteristics is you'll look up a lot of resources, but no one actually connects to them. That kind of looks like what we have going on here. So let's go take a look for that. So I'm going to go in and I'm going to take a look in my DNS.log file. And I'm going to say grep space, and what was it? Cisco dash update. Cisco dash Chris update.com out of DNS.log. And what this will do is this will start showing me those line entries are there. And actually, I'm going to add, let's pipe that through less. There you go. Gave you the command in Discord. Let's take a look at what we have here. All right. So here are my queries for CiscoUpdate.com. Here's the resource within CiscoUpdate.com that I'm trying to connect to. Oh, those look weird, right? Quick show of hands. How many of us have decided for simplicity to name our system 08CD018EA047FCF8FF1EFE1093AB888 blah 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 because it was easy and intuitive to remember and you knew your salespeople would never forget it. Right? These are not things that no, that doesn't happen. No, bad. No. What's going on here? And notice I'm doing MX queries, CNAME queries, text queries for these. I'm changing up the query types I'm doing over and over again. Well, what's going on here? Well, did you notice a pattern when I was reading off these values? That's hex. These are hex values. Someone is sending messages to whoever controls cisco-update.com, which I'm guessing isn't owned by Cisco, and they're doing it in hex because if they did it in ASCII, you may look at that and say, oh, why are database files being transmitted across the internet? Why am I seeing Windows commands as the names of host names that we're looking up? That seems bad to me, but do it as hex. And now it's obfuscated. And yes, like the kitty, it's in Discord, it's all kind of hidden and you don't see what's going on. So, what is this? This to me is a clear indication we've got C2 over DNS taking place. This is bad. We now need to look at who's doing those queries. Well, wait, it isn't listed here. And there's a reason for that. The reason is who's doing this kind of depends, right? If I go back to the log file and look, that tells me that 10.2.57.3 is the one transmitting these queries. Okay, is that a desktop? In which case, yeah, that's probably the compromised system. Or is that one of my internal resolvers? In which case, it's not the compromised system. The compromised system is talking to it and relaying the queries through it. I might have to go a little bit deeper. Time to call in the IR team? Absolutely. Absolutely. That and somebody who's really good at the command line of converting hex to ASCII, which you can do with XXD. And that's a little bit beyond what we're going to get into in this class. The first thing I would want to do is extract out the hex from all of these queries and then convert that to ASCII to try and figure out what's actually going on with the system. So to sum it up, first entry, NTP server, look fine. We could safe list that. Third entry, HTTP, they're being a little sneaky with the headers, but it doesn't look like it's a threat. That's perfectly fine. We're not going to worry about it. Second entry, oh, that looks like C2 over DNS. That looks like we have a problem. All right. And with that said, let's take a break. So it's a little bit past the top of the hour. So let's take a break until 15 minutes after the top of the hour. Although I'm going to give you some homework during break, which I know sounds weird. But what I want you to do is go to the lab 3 directory. Where is it? Here it is. Go to the lab 3 directory, run these commands over break. And that way, when we come back, I can assign you the lab to do, and we'll pick up from there and keep going. So I will see you at 15 minutes after the top of the hour is when we'll pick up and keep going. I asked you to go through and process the data in lab 3. So I'm going to go through and I'm going to do that super quick. Zeek, read PCAP. Tell it where the PCAPs are located. It's there, and then tell it where to write out its files. I want it to write it out to lab 3. And then once it's done, I'll go through and I'll get this stuff imported. If you've done this already, great. Now what I want you to do is I want you to go through and hunt it. So we've got some high severity items. I want you to go through those high severity items and tell me, is this something we need to worry about or not? So safe list it, incident response mode on it. Which one is it? So that's what we're going to be doing in this lab here. So I'm going to give you a little bit to go through and work through this one. Any questions, please feel free to just go ahead and throw them into the Discord channel. So like I said, you should have all this up and running. There we go. Read a view. Lab 3. Oh, environment variable logging enabled is not set. Anytime you see something like that, incorrect flag, define dash logs, those are usually safe to ignore.
Hey, Chris.
Yeah.
Sorry to interrupt, but after Rita, you didn't run import.
You're not interrupting, dude. You're stopping me from sitting here banging my head against the wall. So thank you.
You're welcome.
Awesome. See, if I had just copy pasted the commands I gave you folks to be able to copy paste command, it would have been a whole lot easier. So, oh, and actually we got quite a few high items in here. All right. We won't get through all of these, but actually, you know what? Let's back off for a second rather than having you go through and run through this. This is actually a great opportunity to go in and kind of talk about some of the ones that we have in here. So we've got a high item here, 100% chance it's a beacon. It's only 44 connections, and we're seeing UDP NTP. Now, we have seen C2 over NTP, but it's very rare. So if it turns out this is probably a legitimate host, this is fine. I've got a bunch of 52, 226, 138s bundled in together here. That IP address space is Microsoft. This is probably going to turn out to be Windows stuff. And it's the long connection part of it that's kind of grabbing it. What I want to do is look at the beacons. Oh, I got a lot of connections here. That's probably going to give me a bad day. So we'll come back and revisit that one in a second. What I'm doing is I'm going through and kind of getting a quick sanity check of what's actually here. Notice we've got 26 connections associated with this one here. If I go to the next page, yep, 23. One connection running for 7 hours. Another connection here, it's running for 7 hours. Edge.microsoft.com, we get some 41 counts in here. So we're noticing some stuff that's kind of noisy. And actually, we're into the mediums at that point. We're noticing some stuff that's kind of noisy that we could say, hey, anything that doesn't beacon 24 times or more in a 24-hour period of time, don't bother paying attention to that. And that'll actually clean out some of these items. So that may be one way to address this. So we were, and let's actually, I'm going to walk you through doing that now. So one way we can address this is by creating safe list entries, and we've been doing that. But another way to go about doing it is to go in and say, I'm going to go through and I'm going to change the way I want to get to detect these beacons to see if I can't kind of clean some stuff up that way instead. So here's what we're going to do. So I'm going to quit out of this, and I'm going to go back and I'm going to edit that file that Rita uses for configuration. So I'm going to say sudo nano /etc /Rita /config.hjson. And I'll throw this into Discord, folks. And then hit enter once you run that command. So here's the section where we went in and we had added some safe list entries. Now, if I go down below that, I get into the scoring section. This is how Rita goes through and figures out how it's going to score things. So one of the things we talked about was this setting right here, unique connection threshold 4. And we said that's looking if 4 connections or more are done in a 24-hour period of time, it'll evaluate it to see if that's a beacon. And we said, you know, if you're a .mil, or you're the FBI or the CIA and the NSA or somebody like that, yeah, you might need to worry about nation state being that patient because the value of your data that they could steal from you is so high. But for most of us, that's probably a little excessive, right? Like the one I like to use, Sunburst. Sunburst was nation state and it went after commercial entities. So that's kind of the mile marker I use to figure out, could I detect that? And if so, I'm probably going to be in pretty good shape. Sunburst went off every 15 minutes, plus or minus 10%. So about a minute and a half. That means it was going off about 4 times an hour, which means it was 96 times a day. So if I can detect something that will trigger 96 times a day or more, I'm going to be in pretty good shape. Again, for the average organization, average software company, manufacturing, call it what you will. Now, your needs may be different. If I'm running critical infrastructure, yeah, I might want to use a lower number. But knowing that Sunburst was 96 times in a day, I think it's okay to come in here and say, don't think of it as a beacon unless it connects more than 48 times in a day. That's every 30 minutes. So Sunburst was every 15 minutes. We're saying if it's every 30 minutes, twice that amount of latency or more, that's what we want to go in and pay attention to. So we'll see what impact that has. You could also, if you wanted to, mess around with the weights. So this looks at like the time scan. In figuring out, is this something you need to pay attention to or not? Should I be looking at timestamp more than duration versus histogram score? You can play around with those values if you want to kind of change the weighting on everything. But we're going to leave the rest of the beacon stuff alone for now. And I'm going to get out and I'm going to look at long connections. And this is saying, hey, anything that is 4 hours or less, we're going to consider that low. Anything that lasts for 8 hours or longer, we're going to consider that medium. It's a medium threat. Okay, we could increase these numbers if we wanted to. I'll leave them for now. But no, actually, yeah, I'll make a change. That way you can kind of see what's going on with this. So I'm going to launch my calculator app because that's always good to have. So let's say I want to have medium actually be 12 hours instead. Let's go in and make that change because that one's pretty straightforward. So I'm going to change my notes so I know what it's actually set to. And then I need to change my value. Well, all I'm going to do is take what used to be high and change that to be medium because I'm feeling like it's a little bit too sensitive. So I'm going to say 43,200. Then I can delete the rest of those characters. There we go. So now the long connection needs to last at least 12 hours to be considered a medium severity level threat. Now, let's say I want to bump this up to 20 hours. So I've got 3,600 seconds in an hour times 20 hours. So what I want to set this value to is 72,000. So now long connections need to be running for 20 hours or more to receive a high level severity score associated with them. All right, so let's make those changes. So this is going to be for 20 hours, it's going to be this new threshold. And it's going to be for 72,000 seconds is equivalent to that 20 hours. Cool, we're good there. Now, I could go in and I could change my DNS stuff if I wanted to. There's a bunch of different things I can go in here and modify. How much of a score modifier do I want to do if there's prevalence, if there's a low prevalence, all of that stuff is tweakable, but you get the idea. I've shown you a couple of entries going in and how to change it. Let's just work with that. So I'm going to say, I'm going to hold down Control and hit O, and I'm going to write out that file. And then I'm going to hit Control X to quit. And now I'm going to go back to my Rita import command, create a lab 3B, and I'm going to go through and create that. Once I do, Rita, view, lab 3B. Okay, let's see what this does for us. Well, before we had at least a full page worth of high priority items. Now notice that's knocked it down to where we only have 5. Cool. Let's take a look at those. So let's take a look at these first couple here first. So one of the things that kind of strikes me with these first 4 is these are definitely related, right? I got two different source IP addresses talking to, is it 2? No, I've got 4 different source IP addresses talking to 2 different destination IP addresses. So that to me says, and they're all long connection type of connections. That kind of tells me, yeah, these are all related. Now, here's the problem we're going to run into. We're working with a 24-hour PCAP. We only have 24 hours worth of data. Notice these are 23 hours, 50 something minutes. That comes very close to the 24-hour exactly time frame. What this says to me is that these connections probably started before this PCAP capture was created. Why is that important? Well, that's important because if I grab one of these IPs and I go in and I run my FQ command, I pull that up. All right, so this is from the last lab we did, so I'm going to quit out of that. I'm going to move to the lab 3 directory, and I'm going to say FQ, and then that IP address, and I got no information on it at all. None whatsoever. And I'm not going to bother doing it, but I can guarantee that if I went through each of these other line items, it's going to be exactly the same thing. So what's this telling us? This telling us Zeek didn't start until after this connection did. So I missed the DNS query and I missed any header information that could be useful to me because this is going to TCP 443. So it's most likely an encrypted session. The only stuff that goes by in clear text is right after the initial TCP 3 packet handshake. So I'm not going to be able to pick up on what that was. Okay, so what else could I do? Is there anything else I can do to kind of run this down? Well, I could say dig-x. Let's take a look at who's associated with that IP address space. Okay, I don't have a PTR record, but it's pointing back at Azure. So these could be Microsoft related. And, all 4 of them would be, in which case, excuse me, sorry. In which case, yeah, it's Microsoft related. So it may just be normal Microsoft traffic. Now, next thing I'm going to do is I want to see these look like all the target IPs look like they're on the same subnet, right? So now I want to kind of take a look at, okay, who's actually managing that subnet? So I'm going to go in and I'm going to do a who is query. So I'll go in and I'll say, who is, and again, I'll post this in a Discord for you. Who is -h? I got to tell who is where I want to query. And I can do who is.cmu. Yeah, CYMRU, CYM, Chris, RU.com. And I want to tell it, I don't want to do a normal who is query on a domain. I want to do it based on an IP. So I need to tell it -v for that. And then I need to give it that IP address I was working with. So I'm just going to copy that, paste it into here, and then throw close quotes at the end of the whole thing. All right, let me give you this command. So the who is command allows you to go in and do research on domains, like who's responsible for a particular domain. But what I'm doing is I'm telling it, I want to see some ASN information that's associated with that IP address. So notice when I ran that query, it came back and said, oh, that IP address is part of 8075. And the autonomous system number 8075 is run by Microsoft, and it was allocated in 2015. So here's the deal with 8075. Microsoft used to tell us, oh, 8075, that is our management network. that is only run by Microsoft. Our security people are heavily involved. We keep these servers locked down. So if you see any weird traffic going to an IP address that's an autonomous system number 8075, it's just Windows calling home. Don't worry about it. It's not going to be a big deal. And, life was good. And that was true right up until they launched Azure as a public cloud and started moving their own resources. And as part of that, started overlapping this address space with their public cloud, which, as you know, in a public cloud, anybody can spin up VMs. So the issue we have today is we used to be able to kind of trust anything coming out of 8075 as being Microsoft type stuff. But now you can't, because 8075, if someone knows what they're doing, they can spin up a VM and come up within that autonomous system. So if you're new and you have no idea what I'm talking about, don't worry about this. If you're an old timer that learned a while ago that, 8075 can be trusted because it's the Microsoft stuff, that statement is no longer true because they've polluted it by letting people spin up stuff within that space. Okay. Let's see, what else can I try here? Well, I didn't think there'd be anything associated with that, but if it's Windows servers, I might have stuff calling home. So let me try an FQ against it, see what I get. No. That's not what I wanted. That's not what you wanted to do, Chris. Grab that IP. Doing an FQ against that IP address. Yep, nothing comes back. What else can I try? I think I'm kind of stuck. With like what we could run down. I'm kind of down to about the only thing I can think of to try and run this one down or to run any of these down would be to go through, copy that IP address, and then go back to my web browser and go to VirusTotal. And then just paste in that IP address as part of the URI. And I'll send this over to, I'll post this in Discord so you have it as well. And see, what can VirusTotal tell me about it? In other words, I'm not really getting anything. Let's see. Christy S says, I got thunderstorms rolling in. Hopefully I don't lose power right at the end. Hey, are you in Southwest Florida? Because I'm in Southwest Florida and I have thunderstorms rolling in and I have that exact same concern. So, and you're in Ohio. Oh, okay. Yeah. So it's probably not the same storm cloud bugging you that's bugging me. So what we ran into was we kind of exhausted what we could get out of the Zeek logs because all we really saw was that the connection ran the whole time and anything useful happened before the PCAP actually started. So we're kind of down to one possibility might be, hey, go to these boxes and reboot them, right? Just power cycle. And when they reboot, they're probably going to connect back up to these same systems. And when they do, we'll be able to see the DNS query. We'll be able to see the TCP header. Well, wait a minute, Chris. You said, don't cross the active passive line. Don't do anything the user might detect or the attacker might detect. Well, but reboot in a box, people do that on occasion. I'm not sure that's something that would actually raise a lot of red flags. But point taken, you are technically crossing that passive active line by hitting reboot on that system. So that's one possibility. The other is start using some tools like VirusTotal, go through and start researching these things. Here's what I look for when I do that research. So we looked up this IP address and it came back with all these fully qualified domain names. Notice all of these are Microsoft domains. Windows.com, that's Microsoft. Trafficmanager.net, that's Microsoft. So this has been a Microsoft controlled IP address at least going back to 2019. That's pretty solid to me if I can get 2 years of history like that. Obviously, here we have more than that. If I saw a situation where, it was associated with this domain and then this other domain and then this other domain and then this other domain, I'm going to worry about that more. But this to me looks a little bit more like, yeah, okay, this one's kind of solid. So where am I going with this? Where I'm going with this is that I kind of feel like those entries, these 4 long connections we have right at the top here, this is going to end up being normal Microsoft traffic. It's probably going to end up being Windows notification services, right? So Windows notification services allows you to register applications to send you notifications that can pop up on your Windows machine, and they'll run that stuff through Microsoft servers in order to be able to do that. So that's what the notification service is for. So that's these first 4 items that we have. So now we're down to this one here. So this one was only running for like 4 hours. So it's not, the 24-hour problem that we were running into before. So I don't think I need to worry about that one. But there's a 97% chance there's a beacon here with 13,000 connections. So yeah, there's a lot of that going on. That's something to be concerned about. So let's see, what else can I look at with this one here? Well, let's go back and kind of do our standard stuff. So I'm going to open up my other terminal, and let's see, 172.208.5175. So I'm going to say FQ 172.208.51.75. Okay, this is interesting results. So there's no DNS information associated with it. There's no HTTP information associated with it. There is TLS information associated with it. And it says when it connected to that IP address, there was no SNI information. And I couldn't validate whether that digital certificate was okay or not. Oh, that's kind of weird. Okay, let's take a look in SSL.log to see what we can learn about this connection. So I'm going to say grep that IP address out of SSL.log, and I'll pipe that through less -s x40 just to be able to kind of clean it up a little bit while it's on the screen. Actually, instead of running it through less, let's just run it through head. 10 lines of output from that should be plenty for what we're doing. Okay, what are we looking at here? What I was looking for was that this session is using TLS version 1.3. Ouch. Here's the problem with TLS version 1.3. TLS version 1.3 is designed to obfuscate the SNI information so that you can't see it, which is supposedly done for privacy, which is fine. But my issue with it is we have no way to kind of validate it. In other words, I can't see the digital certificate on the server that they were talking to. So I don't know what resource they were trying to get to. There was no DNS query that took place. So I don't have that to be able to work with to be able to figure out if this is something I can actually go through and trust or not. So my challenge at this point is because it's TLS version 1.3, I don't really have a good way to be able to go through and run this one down. That's a problem. So what can I do? I'm kind of in a situation where I'm a little lost in what I want to be able to do. From a network perspective, I'm kind of down to what's this port? What's usually associated with that port? Well, if I do some Googling around that, I kind of come down to it's, potentially a, what was this thing? It was like an appliance mail server or something like that. It was some sort of an appliance. This was the management interface that was associated. And that to me just kind of seems like it's not really likely. It's unlikely that one of our users would be reaching out to a system out on the internet to say, hey, what's this appliance? Or I want to, hit the management interface on this appliance, this hardware device. One of the things I can do is I can go in and do my dig command again, and I can see what's associated with that IP address. Where is this actually going? So we paste that in. Well, it's going to Microsoft. Well, that's kind of weird. A hardware appliance I would expect to be on somebody's on-prem network, not within Microsoft. This is going to that 8075 that we talked about that, hey, you used to be able to trust this, but now you can't. So what's going on here? About the only thing we have beyond the port is this. This is the hash of the SSL TLS client hello. So when the connection gets started, we make a hash of that client hello, regardless of whether it's encrypted or not. And then we also make a hash of what the server comes back with. And then that gets stored into the log files. So there might be, maybe, something associated with this. Let's take a look. I'm just kind of winging it here. Don't mind me. Let's see. Gray noise fingerprinting attacks with IP similarity. So this is saying, yeah, that's associated with a hash for a known attack pattern. An attacker's guide to evaluating honeypots. And here's one of the hashes they're talking about using. Post-exploit activities. Here's a hash that they were looking at. Notice a pattern here. The pattern is when we look up this JA3 hash that's associated with the client connection, we're hitting a bunch of things that are saying, yeah, this is used in all these different types of attacks. Yeah. How Darktrace provides a sliver of hope. Okay, so Darktrace tries to go in and do detection of malicious activity. And hey, here's the hash along with this thing that they're going in and looking at. Associated with Golang doing a TLS connection. Okay, cool. So, but I'm seeing enough stuff here that looks evil to say, yeah, I'm really kind of feeling like this might be something I need to be concerned about. So I don't know that for certain yet, but I'm definitely leading that way. But notice how badly it goes through and it hoses us just because they were using TLS version 1.3. This is one of the reasons why I hate that protocol. I really advise folks to try and stick with the TLS version 1.2 because you lose complete network visibility once you start using TLS version 1.3 and add like DNS in on top of that. And oh my God, it gets a whole lot worse from there. But there's one thing. So I'm pretty certain this is evil, but I want to point out something. This evil system, 8075. Remember I said we can't trust that block anymore? Hey, here's something you can refer to show you that you can't trust that block anymore. So yeah, this is bad. This is really bad. So let's see. I got a couple slides on this, I think. So yeah. So with TLS version 1.3, the SNI can be obfuscated. It can be encrypted so that you can't see it. So our network tools are basically useless at figuring out what users are doing. This makes our lives really difficult. Now, what's kind of interesting about this is that we're not necessarily completely out of luck. The one that we just looked at, we couldn't get any host information associated with it because it was doing a direct IP address connection. But for a normal system, even if it's using TLS version 1.3, there's going to be a DNS query that takes place first. And we can actually go through and leverage that. In other words, let me show you. Yeah, here we go. So I'm catting the SSL.log file. I'm using zcutter to pull out the destination IP address, the version of TLS that's being used, and the server name that's associated with it. And then I'm saying run that through grep and only show me TLS version 1.3 connections, and then sort it. And unique says just print one line. If it connected 50 times, I don't care. Only print out one. I just want to see all the different unique instances. Now, here's that one we were dealing with here, right? Excuse me. But notice some sites do actually use TLS version 1.3 and not encrypt the SNI information. So sometimes we can actually still go back and look at the SNI information to kind of figure out what's going on. But sometimes it's getting obfuscated. So for example, this is going to Microsoft, this is going to Bing. So my guess is this address space is all and look, they encrypted the SNI so you couldn't see what was going on. R-bang. So, maybe something in this range here. Yeah, it's all getting encrypted. They're encrypting the SNI information on, well, it looks like these are probably all going to end up being Bing. Why would they do that? Well, they use Bing to do a lot of their pushing of ads. So it doesn't surprise me they're encrypting that, because that's the type of stuff people like to block. So if they can stop you from blocking it, they can continue to pop up ads on, your Windows 11 system, so that they can generate a revenue stream off of that, because as we know, Microsoft doesn't make enough money already. Awesome. Okay. So is there anything we can do to kind of figure out what's going on? Well, like we said, this is that command and control server we were looking at. These remaining entries here, though, these are the ones that were kind of mixed in with this stuff, right? It was just, hey, the header didn't get printed. So if we go in and we query those, one of the things you'll notice is that there was a DNS lookup that took place for that host. So, excuse me. So 2353.4.107, there's no SNI information to work with, but there was a DNS query performed, and we can go through and we can use that instead. And if you look at what actually takes place, oh, I did not put it in here. Really? I didn't put it in here? Wow. Okay. So what you'll see is, actually, let me pull up the log files. I'll show you what you'll see. Can't believe I left that out, because this is kind of huge. Okay. So let's use the last one just because it's a little bit easier to see. So we've got what is it, 52, 120, 123, 251. Did I do that one down here? No, I didn't. Give me just a second. Yeah, okay, we'll go with the 23. All right. So if I say FQ 23.53.4.107, that comes back and tells me, yeah, there was a bunch of DNS queries associated with that. Bing, SNI was hidden here. Oh, but it did show up here. Let's find one where it was totally hidden. So I'm going to say, let's try the 25 address. Good. So notice when we connected to that site, the SNI information got scrubbed. We can't see the fully qualified domain name of the server the user was trying to talk to, which means we also can't validate whether the digital certificate. But look up here, we get to see, hey, the user did a query from Bing. And that's what brought them to this address. Okay, that's kind of interesting. Now let's take it one step deeper. I'm going to say grep space 2353.4.25. And I'm going to grab that out of the DNS.log file. I want you to notice a pattern here. Okay, you know what? I should try and clean that up, output out a little bit. What I'm trying to do is I'm trying to show you the different queries that were taking place, because that kind of shows us what's actually going on here. So let me do this one. So I'm going to say cat dns.log file. I'm going to pipe that through, and I'll give you this command, zcutter, because we want to go through and we want to extract out certain fields. What I want to extract out is query, and then I want to extract out Q type, and then what's the other one? What else do I want? Oh, actually, I want Q type name, because Q type will just give me a number. Q type name will actually give me the name of it, and then we'll look at answers. And we'll look at that as part of this as well. And then I'm just going to go through and I'm going to pump that through less. So let me go through and copy that out for you. There you go. Now you get this command. And it's in the slides too somewhere, I'm sure. But I want you to notice a pattern. A record query, HTTPS. A record query, HTTPS. A record query, HTTPS. What's going on here? What's going on here is the user is looking up that website, www.bing.com or whatever. It's looking up that website and it's getting back an A record that points it to the IP address. And then when it goes to talk to the server says, hey, I support TLS version 1.3. We could encrypt that SNI information if you want to make the life more miserable for the security people within your environment. And the browser on the user's desktop says, yeah, I absolutely want to do that because you might be connecting to something that'll serve up banner ads that my owners will make money off of. And the company would normally block that. They'll have a hard time with it. So I definitely want to encrypt this. So the server says, cool, come back and do an HTTPS DNS query for my fully qualified domain name. And what you'll get back is my public key. And since I have we can go through a Diffie-Hellman exchange and we can create a shared secret that you and I know about, but nobody else does. And we can use that to encrypt the SNI information. So I might not be able to find the fully qualified domain name in the HTTPS session anymore, but I can find it in the DNS queries. Further, if you want to stop this crap on your network, go to your DNS. Now, not all DNS servers support this. So it kind of comes down to what you're using for a DNS server. But a lot of DNS servers like Bind will let you filter on different query types. You can tell a DNS server never respond to this. If somebody asks you this query type, ignore it. Ignore it. Don't do anything with it. And you can tell it, ignore HTTPS queries. When you do that, now your users can use TLS version 1.3. TLS version 1.3 works out fine. But since the clients can't get that public key, nothing gets encrypted anymore. Now all your tools start working for you again. So going down the rabbit hole, if you want to keep, stuff so that you can actually work with it, messing with DNS is a good way sometimes. DNS is an awesome tool because it's kind of the core that everything relies on. So if you can implement security at the DNS level, you can do a lot of cool stuff. Like, so I know both Bill and I used to do this. We used to go in and take some of these well-known ad sites, right? Of course, I'm spacing on any of them at the moment, but there are domains that are known to be serving up banner ads, like DoubleClick. The Google end up purchasing. DoubleClick was you never went to DoubleClick because there was something there that was interesting. You went to DoubleClick because it was serving up banner ads. Well, one of the things you could do with your DNS servers is with your internal resolvers, you can say, hey, you're now authoritative for DoubleClick.net. And every fully qualified domain name within that domain resolves to the IP address 127.0.0.1. Well, now what happens? Well, now the browser would go to a site. The site would say, oh, hey, go to DoubleClick and get some ads because we'll make lots of money off of that. And your browser says, sure, no problem. Let me just ask my DNS server where that DoubleClick server is located. And it says the loopback address. Well, most clients don't run a web server. So it tries to connect to port 80 on itself. And it would say, oh, hey, that service is not listening. Okay, I just won't load the banner ad. Not a big deal. Let me show the actual content the user wanted without the banner ads. And, life is good. So cool stuff at the DNS level to get around these. All right, I will get off my soapbox. So we are coming up on the top of the hour. So I'm going to make a couple little tweaks to the end of the class here. And one of those tweaks is Lab 4. So one thing I wanted to warn you about is that when you go to import data into Zeek, you're going to get this soft error. Line 30, failed to open GOIP, blah, blah, blah. It'll say some stuff after that. That's a soft error. Don't worry about it. What's a soft error mean? A soft error means, yeah, it throws that error code, but it's still going to work and everything's going to run fine. It's just a file that's not a location that Zeke can access. And, that's something we could go through and we're going to tweak. But same things you've done before to go through. I'm going to give this to you as homework. I'm going to give you this as something that you can go through and do on your own once you get out of here, because I have the answers for everything in here. So what I want you to do is import it. So don't do it today. Here's what I'd like you to do. I'd like you to wait at least a week and then come back here, run these commands, and start going through the reader data to see, is there anything in here I need to be worried about? I loaded up a known to be very noisy data set. By that, I mean there's like 3 pages of high priority items or critical items, right? There's like, there's a lot of noisy stuff taking place on this network. But there may be interesting stuff buried in all that critical. And what I wanted to do is give you something where you can repetitively go through this process of hunting to really kind of help hone your skills. And all of them have answers to be able to go through and hit. But wait a week before you go through this. Why? Well, because today you've been listening to me talk about this. It's all fresh in your head. So to go through and hunt something, yeah, we've been doing this for the last 5 hours and 45 minutes. So you've got to count down kind of cold. Some of this information you'll retain, some of it you won't. So wait a week and try again. And if a week from now, the stuff you retain, yeah, that is actually soaked into those little gray cells. But there'll be stuff that you're like, wait, what do I do next? What was that dig thing for? What was this? What was that? There's the weak spots. These are the things that slipped through the gray cells and fell on the floor. That stuff you need a little bit of extra help with. Go back through the slides on that content. So it'll kind of help you figure out, what you need to worry about, what you don't. So once you do that, then you can go through and kind of look at, do I want to go through and I want to safe list any of this stuff? And you could actually practice, safe listing with some of these new entries. We've done that before, but you could go through and you could do it again here. I just kind of jump. So we made it as far as 173. So clearly, Chris added in way too many labs. So I need to tweak this. I was a little optimistic in how much we could actually cover in a 6-hour period of time. But it's in there. It's in the slides. You've got it. You can go through it. And there's also some opportunities to be able to go in and make some changes to how things are going through. Just remember that when you go in and you change that config file, you want to go in and recreate your database again. Once you do that, you can review it and you'll be in pretty good shape. And I gave some other recommended changes you can make with Zeek. Oh, I didn't show you this. So if you're old school Rita, if you're saying, gee, bubble tea is nice, it has colors, but I miss the comma separated output I used to get out of Rita, there's an undocumented switch for you folks. And that is you do Rita space view space dash std out space the name of the database. And when you do that, it's going to go through and it's going to print out everything in comma separated format for you. Actually, let me do that one just as kind of like a last lab in this whole thing. So I'm in, let's see, where am I on the lab 3 directory here? So I'm going to say Rita view dash std out, and I'll tell it I want to take a look at the lab 3 data set. And then I'm going to pump it through head, and I'm going to say dash 25, only show me 25 lines worth of output. So now rather than having a graphical interface, and it's still scrolled off the top of the screen using 25. Probably should have done that for 20, but you get the idea. If you miss the comma separated format, it's still there. It's just an undocumented switch for you folks. Cool. Want to make sure I covered that. So closing thoughts. So remember, again, a lot of this is about remember that process. Go in and look for connection persistency first. That's what we're using Rita for. Rita was helping us figure out when are these systems in constant contact with each other. If so, now I need to figure out, is there a business need associated with that? If I can't immediately identify a business need, now I'll do some investigation work on that external IP. Maybe I can do some work on the internal IP. And the idea, like I said, is to come out with, hey, I'm pretty certain that system is safe, or hey, I'm pretty certain that system is compromised. If it's safe, it goes, that entry may get added to a safe list. If it's not safe, yeah, we're now going into incident response mode. Once you get through the additional slides and practicing with those, if you want to keep going, we have a blog series we do called Malware of the Day. And what you do is go to the blog entry and don't look at it. Skip way to the bottom, because at the bottom is where we include the PCAPs that are all the captures from this malware, and download the 24-hour capture file. Now, run it through Zeek, run it through Rita, hunt it, see if you can't figure out what's evil in here and what's not. When you think you have all the answers, go back to the blog entry, check your work. So it's a great way to be able to go in and kind of practice to see, how's my process? Am I catching everything that I should? Mention this, if you want a demo, just type in demo. Classes I'm teaching, talk about that. So certs. So certs usually go out within about a 24-hour period of time. So what I'm going to ask you is wait until Monday morning. And if you start work Monday morning and you don't have your cert, fine, go ahead and email us. Say, hey, I didn't get my cert. What's going on? Throw it into Discord, whatever works for you. But we have a couple of different ways that we're going to be delivering certs now. One is via email. So if you attended the class and you actually showed up, you'll get an email with a link to your cert. But we're also going to start throwing them up on a Credible. So if you go in and create an account in a Credible, now you don't have to wait for the certs to show up via email anymore. They'll all just get loaded up there for you. So now you'll have access to everything all in one spot. And that's all I've got. So with that said, Bill, Keith, everybody else, anybody want to add anything in before we call it quits and call it done?
No, just that was awesome again. I mean, and it was refreshing doing Rita, something new. So it was really cool.
Yeah, that was kind of my thing too. We've done AC Hunter, the community edition, for like a year. I wanted to kind of mix it up a little bit. And it was kind of good to see how do people respond to like intensive command line work.
Yeah.
That's good. I kind of tossed in.
Yeah.
Hey, thank you very much to everybody who had good questions today, and also for everybody who helped each other out. We really appreciate that. That's what that Discord server is for, that we can all share the information we've got.
Yeah. And that is one thing I absolutely love about this community is when someone says, I don't get this or I'm new, they don't get hate, they get love.
Yeah.
It's always, yep, that was me 6 months ago. That was me a year ago. Yeah, I had the same question when I started. Everybody kind of relates.
That was me 5 minutes ago.
Yeah, exactly. Exactly.
Great. But you're right, and that's a great point, because that is very important. I mean, we all have information that somebody else doesn't. It doesn't make you better. It doesn't make you special.
Nobody knows everything.
Yeah.
Thank you, everybody, for giving up your day and joining us. We really appreciate it.
Yeah, and that's something that we do keep in mind is that this class is called free, but it's not. You gave up 6 hours of your life, plus if you showed up for pre-band, you gave up a whole day's worth of time to spend time with us. That has value, and we do appreciate you spending that value with us. So thank you, folks, much appreciated. I apologize for the little bugs in the process. New version of Rita, new set of slides. That will get things cleaned up for the next time through. And for those folks that were saying, "Hey, I kind of followed some stuff, but not another," please come back. We have never told someone, "No, you can't attend. You showed up already." That's never ever happened. It never will. We love having we call you repeat offenders, but we do it with love. We love having people keep coming back, and that's like I said. I think it's after you've attended this class 15 times, Shelby starts just sending you swag. It's like you're almost part of the company at that point. We're just going to start sending you free swag. So
great,
awesome. All right, thank you, everybody.
Hey, thanks again, Chris, and big thanks to Bill for all your help, and Joe Jones, Aaron, and Eric G. I mean, you guys.
And Shelby.
Yeah.
Yep.
No.
Also, just want to mention.
No, thank you to Shelby.
Yes, 100% thank you.
Everybody else but Shelby.
Chris, if you weren't in Florida, I'd hit you in the back of the head.
Yeah. If I ever want to see my grandkids again, I better change to it.
Yeah, I would.
Luckily,
thanks, guys.
Luckily, she's been around me long enough to know I am totally joking. So.
Yeah. Shelby's awesome. And real quick, I just want to mention one more thing that Chris made some great videos about Rita that are landing on YouTube. He made a series of 6 of them. 2 of them are already posted. The remaining 4 will be posted each day next week. So I'm going to throw a link to that in Discord.
Awesome. Yep. All right. Thank you, folks. It's a weekend. Go have fun. Thank you, everybody.
Thanks, everybody.
Later.
Bye.
Bye.